That was a good evil laugh. It was very spirited, but I was checking my volume the whole time. If I can actually get loud, which I'll be able to do tomorrow, I'll be able to get loud because I've got the whole house to myself and Julian, then I can do a proper evil laugh. You need to really put volume into it to make it sound good. It gets all the vocal fries and whatnot behind it. What am I doing? Okay, this is live, YouTube is live, YouTube chat is not. We go over here, we go to this, and I go, hey, go away. And then I say, hey, find and activate. Here we go. This is Social Stream Ninja. If you want to get 2 chats in one, this is a marginally easy way to do it without a lot of weird sign-up stuff. It does all these services that I'm never going to use. And I don't know, it's just a chatter told me how to do this because they are the tech guy on their wife's stream. So good stuff. It works pretty well, and it's what's powering these things. These things are just looking at a website on the intranet. And actually, what I'd like to do is get that running on the laptop so that when Julian's over there, he can see you guys still. But I have been diagnosed with a terminal case of being a little bit too lazy and having marginal executive dysfunction. By the way, these things we determined, these guys, we determined that the AliExpress ones can sometimes be way too much force. So these are not safe for me to order for the thing. People keep coming up with these and then being like, hey, Bother, why don't you just buy these? No, I'm gonna opt to spend a little bit more money for the peace of mind that I'm going to get the right stuff. I think that's kind of worth it. Oh yeah, that was for a Nightbot command. By the way, there is a BTS viewer, if you were part of the scene 5 years ago, 6 years ago, of all of the, hey, there's Vamp there, all of the subbing and burning and fun stuff like that. You can find your name on the big board, the 4,413 name board. I don't think this is right. I don't know if this is right. I'm wondering if it looks complete, but it does look like there are areas that might fill in. I think we were closer to 6,000 names. This might be a slightly earlier version of the database, but I thought I hosted the final version on GitHub. Oh, that's an underscore. I thought that was... It's cool to be able to browse it like this, though. I hope all these people are still alive. Some of them are probably dead. Anyway, this is a cool thing. Back to here. Let's put you guys back on my monitor. Are we getting side channel attacked? Is that what's going on? Is that why the question was floated? Don't need this. Don't need tactile switches. Okay. A little bit better. A little bit better. And these are the... This is where I'm going to order the parts, basically. Yeah, could you put together a 555? This would be the worst way to use a 555, though, without any of the stuff on it. It would hurt. It would hurt to use like that. Where's our repair manual? That would be this one. Okay. We're going to have to see about, I think in here somewhere, yeah, there's the version number and then user data, and then we've got things that will go into test mode. Test mode, this is going to be a good one. We may play with this. What I'm going to do first, though, is we need to test all these buttons. So I need to figure out what I need to order or not. Man, I go on a little early and my viewers are just gone. That's kind of neat. I wonder if we're going to go above 23. Oh, am I being... maybe Twitch has noted... Twitch has found all of my bots. The fact that all of you guys are just cell phones in a closet over there. And so I don't have any viewers. Now, it's because it's Friday. Hopefully everybody's touching grass because it's absolutely beautiful out in Pennsylvania, at least. I don't know about those of you who are overseas. Punch a baby. Please don't try to remote pilot your streamer. You guys know that I'm going to get to that. Hello, I am a bot. You just proved you're not. What's up, Magic String? That's actually a pretty good username. I like that. It is I, the dog. I have opened up twitch.tv/ohbother, and I am viewing this stream. Hello, it is me. Yeah, there's a lot of big channels, and Lord knows, I do not watch these people, people with 10, 20,000 viewers. I have one, well, two. It's Germa and Moon Moon are the only two above 10K viewer streams that I even bother with. But they don't give a shit about their viewers. They don't care about how many people are watching them. I think the comedy is so good. Like, what if everybody just unfollowed celebrities on Twitter? Just completely unfollow them, and their social medias will be completely boring. They would have such an ego meltdown. And that's happening to some streamers who have never been below 2,000 viewers. These people who have 11,000, and obviously now we know 8,000 of them are bots, but they are getting rate limited by Twitch in their new crackdown with bots. So it's actually really fucking funny. Oh, I shouldn't have cursed. I'm sorry. YouTubers, plug your ears. I'm so sorry. Oh my God. Everything at once. I wonder if Willow knows that your stream is starting soon and has the idea to ask how you doing. The fact that you baked that into a single comment and it blew up all of my visuals all at once is exactly why I do what I do. There are certain things that you say in Twitch chat that will trigger those things. I have a page open on my other computer and I need to play around with it. A thing that will get YouTube chat into thingy-majig, into those flows, into those Node-RED flows. Did I say hi to MadameU? I forget. I think I did. Well, I did now, just by doing that. But yeah, these channels, what's happening is these bot-heavy channels that are making themselves look like they are super popular streams will sweep up a bunch of regular people because they're so big. So you have like a 20,000 viewer stream dropping down to 2,000. And the host is melting down because they're like, well, that's it. Nobody watches my stream. If I had 2,000 people watching this, I would be shitting my pants. That would be a pants shit. That would happen live on Twitch. That's what you guys tune in for, and it would happen. Oh, I said the S word. I'm so sorry. That's technically a curse. I'm so sorry, YouTube. I'm so sorry. YouTube is just throwing my viewers out a window. Nobody's ever gonna see my stream ever again. You'll never work in this town again. You filthy curse word utterancer. I think it's only in the first few seconds, but I have a feeling there's something that goes on in the background that even further censors you on YouTube if you use naughty bad words. What I would like to do is somehow access a transcript of what I'm saying so that as I talk, I can actually trigger all of those visual things that you guys see going on. So if I say Willow, then Willow pops up on screen. I think that would be very funny if I said Willow and Willow pops up on screen. I have a button that activates the Willow thing. So you guys get a picture of the dog. If you guys say Willow in chat, you get a picture of her. She is my whole world. Yeah, Idea lights up specifically the Idea light, which oftentimes I will forget about, and then you guys will suddenly blind me with it. It's not even that bright, but it still blinds me. Look at that dog. I needn't to tell you guys that these things exist, because as soon as you tell chat something like that exists, they go crazy with it. Okay, let's get the music out of here. This is a really good mix. I really like this mix. Low pressure mix from 8-Ball on the Space Cowboys. But anyway, hi, what's going on? Well, this is going on. We got this giant piece of musical equipment, this weird sort of relic of the 90s that I used to have in the 90s. The year I think we got one in 98 when this thing was the hot shit. I never got to learn how to use it. It's a lot of menu diving because it only has a character LCD. So there's a lot of menu diving. These kids now with their new tools. This is like the foyer into digital music stuff on the wave of analog synthesis. This is just at the end of all of the digital, just at the beginning of the digital stuff. when we've moved over to microprocessors instead of having analog stuff that we can adjust with. The advantage of this thing is that it's a sequencer and it does a lot of cool arpeggiating and stuff like that, things that digital really kind of brings into the fray. So I've wanted a 505 for a while. They were expensive and then they were probably really cheap, and now they're just kind of a little cheap. I bought this one because it's broken. It is broken. The thing we've seen so far to indicate that it is broken is that all of these buttons are just suck out loud. They're terrible. These have been used. This thing has likely led a rich and fulfilled life of musical synthesis, but it needs some new bones. So we're gonna put new switches on it, but before I do that, I actually do want to test some of these other buttons to make sure that they are doing what they're supposed to do. We've noted that some of them don't like work, like nothing happens when you hit them, but nothing happens when you hit them does not necessarily mean that they are broken buttons. It might mean that this thing is in a mode where hitting that button doesn't do anything. So I need to go through and I need to check at the cables whether or not, as we cycle through the matrix, the rows and columns of this thing, that we are actually seeing an activation from those buttons. I missed the pre-stream stream. I missed when Bother pre-streamed his streaming stream. And when he streamed the streamer, I don't remember what I was saying. I started a little bit early. I was sitting behind my computer and I was like, you know what? Let's just do this. So yeah, we're gonna go through with the scope, and basically what we're gonna look for are just little bumps in the voltage. Because what happens is on a keypad, you will have a button and the button simply shorts out something, right? Well, if you have just buttons and you have one pin per button, that's great for you. I'm glad you're rich. If you don't have that many buttons or don't have that many pins on your microcontroller to sacrifice to buttons, you do row and column scanning of a matrix. It's not the Keanu Reeves thing. It's not the math thing. It's an electrical circuit thing that you do, and it looks a lot like this, where you have a button that shorts out a resistor to ground. So the resistor going to ground holds this at ground potential. When you activate 5 volts to a row using a transistor and you hit that button, the short circuit to positive power will override your resistor to ground. It'll overpower it and it'll create current flow here that'll hold this at 5 volts. And so if you look at that on a microcontroller pin, basically what you need is in the case of this keypad, you would have your 3 active transistor leads, and then you have, 7 pins of the microcontroller dedicated to like 32 buttons. 1, 2, 3, 4, 5, 6, 7, so 8, 16. Yeah, so not 32, but a little less, but it's rows of 8. So yeah, that's the scheme that we're looking at. This one is fairly unique. These are the keyboard buttons and a couple other things, but the cool part about what these do is these are actually sending a pin high that goes into a 7400 series logic chip. The TC74HC, blah, 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 blah. This 7400 series is what's called a bus transceiver. So if you have a bus with wires that need to go a long distance, this thing can bolster your bus, or it can even have your bus go to a different voltage level, although I don't think that's maybe the original intention of this chip. You can also activate and deactivate the entire thing, but it looks like they just hold it and in activation. But what this can do is make sure that your bus gets there and it's not going through a ton of wire and losing resistance. It'll bolster your signal. And the weird thing that they're using it for, yeah, buster bolster, binge or bimbly, I don't fucking know. Anyway, what's going on? When you hit a button, it hits the bus transceiver, and the bus transceiver activates the other line, which then turns on an LED. So the flashy LEDs that we were seeing were because these switches were not making good contact. They have been used too much. They are beyond their lifespan. And so when you push the button, it's making this sort of intermittent contact. And we see that directly in the LED because the LEDs are driven directly. This is not how you would do this in a modern piece of digital equipment. Modern piece of digital equipment, you'd have like a test mode where all the blinking lights are going off and stuff, or you would have like the player piano playing the different notes for you. That I guess doesn't happen here because you're activating them individually. Actually, can it though? I think the controller could hold that line and activate it. I think, yeah, maybe that's what they're doing. They have both the buttons and the LEDs on the same line, so they can activate the LED, but if you push the button, it'll activate the LED and they don't have to do anything. You're maybe saving a couple cycles of the microcontroller for that. It's a weird scheme. I've never seen it before. It's sort of fascinating. Do you remember at what wire distance you're supposed to use a transceiver? No, I don't. I do not know. Especially in this era. I mean, if we look up the part, I think I just closed the window. Hold on. These Firefox features are very annoying. That's DigiKey. That's that. That's 007. That's AliExpress. That's that thing. Okay, we'd save more time just looking it up on our own. Problem is this puts spaces in between all the things because it's a scan. Why would you use this? Where does this come in handy? I do not care if it is in stock. I simply wish for a datasheet. Octobus transceiver, that just means 10. There's an inverting and a non-inverting. High-speed CMOS, that's 5 volts, octal bus transceiver, fabricated with silicon gate CMOS technology. C2MOS. See, Thomas, do you see? They achieve a high-speed operation similar equivalent to while maintaining the CMOS low power dissipation. They are intended for two-way asynchronous communication between data buses. Okay, the direction of data transmitted is determined by the level of the DIR input. To enable input, is it for isolation? Output current, balanced operation, wide operating voltage range. Do not apply a signal to any bus pin when it is in the output mode. I do not understand. It seems like they've got... Yeah, it's just you enable a certain direction. You have to enable the direction too. So maybe it is isolating between the two. Why would they put in a 7400 series chip like that? You push a button, it goes into the bus isolation thing that's in this direction from B to A, and then it asserts the voltage level on the line at A and turns on the LED. But you're not supposed to use these as an input. So if I were to assert a voltage level here, it could harm this chip. Yeah, Wyant indeed. I mean, they just told me if I assert a voltage level on the line here, trying to go the opposite direction, that could harm the chip. So my theory about this being a method to flip these LEDs on and off might be incorrect. These lines are just going to be input lines to the micro through whatever isolation. And if I set that line high or low, I feel like there still has to be a way to flip these LEDs on remotely. And I'm guessing that's what these are doing. Yeah, but here's the direction pin, and it's, oh, wait a minute, no. Okay, so yeah, the microcontroller can say, hey, flip your direction, I'm gonna turn on some LEDs, bitch, and then it does, and then the asserted line over here doesn't matter, it'll just be turning on and off the LEDs. Okay, so that settles that. Okay, I didn't see that there was a line coming off of this. I thought they had just permanently wired it to ground. Nope, they have it going to ground unless the microcontroller asserts otherwise. Wait, but what's G? Direction. VCC. There's a different chip. Are we looking at a different chip? What's going on here? See, there's G and direction. And G is opposite day. G. GG. G. What is G? What are G? G. G. Inputs. G. They don't define what G. Why is it G? Why is the letter G? Direction? Gain and direction? Gdur? Do you know the dir of the nerd rhyme? Low, low means A bus is out, B bus is in. So that would be the default. And then high, high, it doesn't matter. That's canceled. It just cancels it out. So basically the microcontroller will tell this thing to go high Z. High Z means high resistance. I don't know if that means you can hurt it or not. Yeah, high impedance is high resistance. It's very impotent. Wait a minute, that's not the right word. That's not the right word. So basically in normal operation it would be low, low. So A bus would be the output and B bus would be the input. But then, yeah, B bus input, A bus output. And then when that line goes high, it'll just X out, it'll deactivate the chip. These things are so annoying. How do you get out of here? Get that thing out of my face. Okay. But then up here it says, do not apply a signal to any bus pins when it is in the output mode. Damage may result. All floating bus pins must have their input levels fixed by means of pull down. Really? See, I read stuff and I highlight it when I'm reading, and it also helps tell people where I am on the page so that people don't get completely overwhelmed by all of the stuff that I have up on screen. They know where to focus, and these Firefox like little add-on extra highlighting tools are very annoying because I don't want it there. No! What the hell is the purpose of the little thing if I can't click back in? Oh my goodness, I think I need to deactivate the tool. There we go. But then it pops up the pop-up again. Oh boy, the Firefox reader is on my short list. It's on my shit list. Okay, anyway, so that we've determined that's what it does. So when it wants to light up the LEDs on its own, it will set a high signal here, and that'll put the chip into high impedance, and then it won't be listening in, it'll be activating LEDs. So the computer can take over and light up these lights. Because I think it does in one of the modes. I think in the sequencer mode it does. So as they're iterating through all of their different matrices, man, that's a lot for the code to be doing. It's kind of impressive. That's a cool scheme though. I've never heard of doing that before, where you put like a bus transceiver in there so that when you hit the button, the LED turns on. The way that I would do it is I would have different matrices and probably burn up a whole bunch of pins. And you would you could just activate these anyway too as you're iterating through, because as you iterate through, you're either listening in on the pin or you are asserting a high level on the pin in order to light up the light. So you could do that without all of this extra circuitry. I wonder why they isolated it like this. Maybe that just saves a couple cycles of a microcontroller right here. That is fascinating. Anyway, we looked at these, and apparently because these buttons are so old, they barely make contact. We don't know what the light up thing, I mean, the LEDs are old, so they're just not as bright. I think maybe the chips just aren't as good after 20 years of use. Here, let's turn this thing on. Bada bing. And we'll have to play with test mode in a little bit to, really test the rest of it. But I do want to go to the sockets, the buttony stuff. This is like, this is pretty dim. This LED is really not giving all of its go. And you can see I'm just pushing down on this thing. It should have a more steady, hold on, where's my, this should be more steady, and it's flickering. And it's down to the button. So we need to test some of the other buttons. So let's jump into the Matrix. Features all the time with the makers of the Matrix, the music. No, LTJ Bukem is going to be stuck in my head all day, because I'm going to keep talking about these matrices. So this matrix we've looked at. Let's look at another one. At some point, we probably should look at these things. The knobs. I think the knobs are largely in good shape. I don't know. There should be wear on some of the more often used ones. Oh, and I'm gonna have to get a new encoder. This one probably still works, but if you move it quickly, it's not catching all those little in-betweens because the springs have gotten worn out. So we will get a new encoder. Let's do it here. Let's make a list. Let's not forget about these things. AB encoder. All right, broken list. Okay, in my doctor's handwriting. All right, so we need to check more buttons. We could check these things. We'd have to check them at the 74HC 4051. I think that's 4051 you see used a lot with these things. God, I hate that delete, 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 la-di-da-di-da-di-dee-dee-doo. Okay. Data sheet, we want directly. If these things just used all the 7400 series stuff, we wouldn't be having the problems we were having. I don't like all data sheets, all the frames. Analog multiplexer, demultiplexer. So what we're doing is we are switching to various outputs. It's the same thing as those Maxim chips that I have. But it's doing that so that I can use fewer analog lines to read all the potentiometers, because you don't need to get that kind of G for gats. G is for green. You might be right. G for go. Yeah, so multiplex, mux or demux, you're basically, it's just like a selector switch. It's like a digital selector switch for whichever input you want to read, which is a good way to save on pins if you've got older, if you've got sort of early 90s, late 90s digital chips, microcontrollers. This is before the era of the Arduino. Basic stamp, I think, was around then. Not. You're right, it was the 90s. Were we saying not back then? I think we were. Okay, so that would be like these chips over here doing that muxing and demuxing. And I guess, I mean, we can jump through and see what that looks like to the microcontroller if we go to the right pins of this thing. Our schematic is good. This is a good schematic. This makes this repair so much less stressful for me. Having just a nice schematic that has everything marked down in it. We can check the potentiometers themselves by going through and checking on these pins of these chips. So let's start up here, I guess. What else do we have on this page? Yeah, we'll go down through these chips. So we're looking for IC7. This is where if I had the camera on a gimbal, we could, move around like this and search for components. Or if I actually made that camera able to be touched. I can't touch that camera or it'll freeze because of the stupid connector. We'll have to do, the problem is, in order to do like a repair of that camera, I then need that camera to view that camera close up. So I would have to use my really, really cool looking magnifying face piece. Remember when you had to try and reverse the M303 just to repair it? This is definitely nicer in comparison. The M303 was, they're sitting over in the corner. I wish I had a good schematic for them because I am at my wit's end with those things. I don't know what's wrong with them. I just don't know. Yeah, I need to get back to those because those have sat for way too long. IC7 is nowhere around here. What are you? 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 You're not. IC1. Okay, that's pretty far off. I think we're actually over here then. Gotta love 80s and 90s Japanese stuff. This is technically 80s and 90s Japanese, and it doesn't feel like, so the camcorder, the Sony camcorder that I got sent, I really never should have taken that apart, but I did, just because that was the promise. I should have used that camcorder in my production, because it had that nice chromatic aberration and everything. But we took it apart, and I've got the circuit board sitting down on my thing of circuit boards. That's more like Japanese 80s and 90s. It's insane how, like, organized, and it's got a neatness to it that I don't know if I see in other electronics. Cool stuff. All right, IC 8 and 9, so we're getting close. IC 4. Where the hell would IC 7 be then? How did I choose one that just completely... IC 6 is all the way over there. IC 7, there it is. Okay, so this one's on the faders. So, ground on IC 7 is pin 7, 8, 6, 7, and 8. So, like the predecessors, vacuum tubes, we go anti-clockwise from the notch. Pin 1, 2, 3. Okay, so how many pins are there? 1, 2, 3, 4, 5, 6, 7, 8. So these are the ground pins, and pin 9 is right here. Actually, wait a minute. They labeled this is you do not need to do this. You don't need to do this. This comes from the frustration of having to troubleshoot your own designs, is externally labeling the pin numbers. So I've got this little tiny micro clip, and that's just going to hook around that leg, and that gives us our ground. So the first fader, VR20A. VR20 is this one, and then pin 4. Oh, this is going to move all around. If I hook it from the other side, it's a little bit more reliable. These are just like, it's just like a little booger hook. Since these pins are all ground, I'm not worried about shorting them. See, that hooks it in a little bit more reliably because the plastic goes in between the pins. These also work on surface mount, the SOICs. Luckily for us, though, we are through hole and we're 7400 era. 1, 2, 3, and 4. So this pin right here, oh, let's put the scope back on. Dude, okay. So make sure we're in 1X. Yeah, 1X. Okay. 1, 2, 3, pin 4. Oop, slipped. Son of a... Why is it so dirty? I think that's just my grounds being a little dirty. Because the signal looks okay. If I position myself better... No, I think it's just my ground loops are crazy here. Fader's good. Pin 2 is which one? Okay, there's pin 2. Looking good. Why is that at a weird voltage? Is this 6.0? Yeah, okay. Pin 2, pin 5. 1. Why are these all discombobulated? 1, 2, 3, 4, 5. I'm going through these in the order that they're on the schematic. Okay, looking good. I mean, these faders are pretty good for being 20 years old. Pin 1. Why are these? These are in like a batshit crazy order. Oh, that noise is because I was touching ground. Okay, that looks good. Pin 12. 8, 9, 10, 11, 12. This is the side that's much easier for me to get to. There we go. You're looking good. What I'm looking for is like scratching or to have the voltage level drop out suddenly. Uh, 15, 10, 11, 12, 16, 15. Yurt. Okay, that one's good. Pin 14. Guessing that's over here. No? Is it any of these? No, we're somewhere else. Oh no, we're right here. Okay, that was the last one of those. 16, 15. Oh no, 14 is here. Is that... Nope. Is it you guys? Oh, these have a little ball detent in the middle. Cool. That makes them expensive. Well, no, that one does, but the other ones don't. Wait, what? Okay, that's the only one with it. Oh, this must be the overall. It's got a little ball detent in the middle. That's cool. So which one does this go to? What other analogs are in the area? Because this one's in the middle somewhere. These are probably too far away. Yeah, okay. Where do you go? Where do you come from? Where do you go? Cotton Eye Joe. But I've been Cotton Eye Joe. I've been married a long time ago. Where'd you go? Where'd you come from, Cotton Eye Joe? But I've been Cotton Eye Joe. What are you? So this one corresponds to something, and it's an analog, but it's not any of these, because we already tested half of them, and they're good. I don't know about these initial ones. I don't know where they go. And it's not over here. Is it British? They played that at every single dance ever in high school. Every single one. That big Cotton Eye Joe. I've been married a long time. Oh, there you are. Where'd you come from? Where'd you go? Where'd you come from, Cotton Eye Joe? That big blah, blah, blah. As it plays at 12x speed in my brain. Okay, so that was pin 14, and then pin 13 is another analog input. Oh, and it's right here. I guessed it. Looking good. No dropping out, no wiggliness in the knob. These knobs are pretty good. They're in good shape. My ground is just so dirty. I don't know why it's like that. I don't know what to do to solve that. It's probably not that dirty to the electronics themselves, but you see that there's all that noise that's in the shop. I do not know what to do about that. It might be the USB-C power thing that I'm using. Or does that one get its own brick? That one gets its own brick. It gets the expensive Amazon brick, I think. Oh, no, not anymore. No, it doesn't. Maybe I need to bring back the expensive Amazon brick. It was like a $75. It's much cheaper now, but it was an expensive thing when I was sent. Oh, that's because that's for this one. Why is there chaos? I guess it's scanning that a lot. Okay, so that's that analog chip is good. We're just doing this, we're testing this stuff just to make sure that it's okay. Just so that I order the right stuff from this place. If we've got, I want to make sure that all of our input stuff is good. And I believe the output stuff is fine because it's all solid state electronics from there out. This is all just the mechanical stuff that wears away on something like this. So now we're on IC3. Let's grab our ground probe and head on over to IC3 town. Where the hell? IC3, there's 4, 9, 8, 3, all the way up here. Same chip. We're looking for pins 6, 7, and 8. See, kids, you don't get to choose sequential numbers as your haha funny number. Because if I'm looking at pins 6 and 7, it's just too common. It's like ridiculous. It's just ridiculous. You're ridiculous. Pin 4, we're going in the same order. So 1, 2, 3, 4. Pin 4, we get ju. Perfect. So the detent is at around, what is that? 2.8 volts or something. What up, Hairbothan? Yeah, and we go up to 5. Try to put a voltage level on that, but then there's all this noise on the line that's like, I don't know, if I speed up, is that going to look a little better? Slow down. It's just so nasty. I don't know why my ground is so nasty. I think maybe this power supply is not good. And I don't mean the power supply for this device. I mean the power supply that I've hooked up to the scope. The boy, trademark, hates the 6.7 thing. He's 12 now. It's so easy to wind him up. That's yeah, messing with your 12-year-old is a time-honored institution. Pin 2. They don't know how to brush things off and be cool about it, you know? I love it. Julian's strategy for 6.7 is just to go all in. And so you have your teacher of a particular class like just cracking up about this number, and you realize in that moment how stupid it is. 1, 2, 3, 4, 5. Pin 5. I'm gonna guess. Yes, sir. These are in good shape. They're not dropping out. These felt a little bit worn, but I don't think you're using them as much when you're using this device, so that's what his sister's strategy is. It surprisingly effective. I don't know. It's a good opportunity to teach your kids about mumble rappers and the culture and what the police codes of a certain precinct in Philadelphia are, because apparently that's what it's based on. Doing a manslaughter and then hopping on to the next exit of the freeway while they announce the 6.7 on the police radio. Pin 1. Evidently that's the origin of it, but it kind of grew legs beyond that. So that's not actually what it completely means. Yeah, that's apparently, it's from the mumble rap scene in Philly. And this code of the particular precinct that this rapper's from, 6.7 is some kind of I found a body or something like that. With no perpetrator around or something. But they hop on to the next exit of I-76. Oh no, 95? That's 95 because they're 76 doesn't do that. Pin 12. 16, I can't even see the pins from over here. Hold on. I gotta stick my face over. 16, 15, 14, 13, 12. Pin 12. Do-do-do, do-do-do, do-do-do. Oh, there it is. That's the last one. Jeez. Looking good, no scratching. These feel a little bit more rough than these guys over here. I-87. No, that's not around here. Oh, 187 quality rolls? I used to have a t-shirt. I met an ex-girlfriend wearing that t-shirt. I remember that song, 187 Quality Rolls. It was an old electronic song. Probably made one with one of these. What was that one again? Wait, we did 15, 14, 13, right? And 15, I'll check them again. Hold on, 16, 15. Where are you, 15? Where did it go? 15. Okay, fine. 14. What the? Hello? Did I mess something up? Hold on a sec. 16, 15. Well, I mean, I'm willing to call these okay. I just don't know why I'm not seeing a level coming off of this thing. Oh, is this a... No, because we already clocked 2 of these knobs. And there's nobody else in the area. Is it not connected? So 15, 14, 13, and 12 are all assigned to stuff. Wikipedia, doot 67. What does the wiki page say? You know it's serious when you have a 7805. There's no 7805s here. Actually, maybe on the other board. So why am I seeing nothing now? Maybe, I mean, I could have messed it up, but I don't think I did. 15. Why would that now not give me a translated voltage level? 14. Oops. So 16, 15, 14 is here. Did something slip on the ground? Is this making contact when it shouldn't? What the fuck? Wait a minute. Wait. No. Wait. I'm baffled. Like, short something out? I think so. This seems like a me problem. Make sure that's making good contact. This one's good. I should probably modify this to have a, like, modify the clip here to make it go directly to, like, a pin like that. That would be a good thing to have. Those lights weren't on before. Which ones? I can't see which lights. I could have changed modes, yes. But we would still see a voltage level on this because this is still hooked up to power. I don't think it's selectively, yeah, it says D5 plus on it. The lights under the faders? Yeah, I'm not sure. Hold on. Oops. See, those are permanently powered. And we're checking them at the IC pin. So we're not checking them at the scanning thing. And they were working before. ADSR, pitch, cutoff resonance, and envelope depth. Yeah, I'm just hoping I didn't like poke something and get the chip put into a different mode or something. But I mean, we were seeing these work just fine before. It's like, why are they not registering over here? And I'm pretty sure my equipment still works. Hold on, let's check. Pin 3. Yeah, there it's scanning through the different levels. So if I adjust these, you can see it's sort of frantically changing pieces of that signal. This is what you guys get with 60 FPS. You get to see the madness that I typically observe. Everybody up. Whoa. Everybody down. Of course, 2 of them are still. Is that one of them? Doesn't seem like it. Okay, so I'm checking on the other pins because they're a little bit more sane. We were seeing, okay, there we go. There's pin 1. So that's good. Pin 2. That's good. Pin 3. That's the signal output. Pin 4. Good. 5 is not, what is 5? 5 is, okay. 5, 6, and 7 are the, no, 6, 7, and 8. What is 5 doing? Pin 5 is another fader. Okay, so hold on. 1, 2, 3, 4, 5. There we go. Let's see. 6, 7, 8, ground. 9 is something else. It's like C. Yeah, so that's it sending the the muxes. Well, no, that's something else. Maybe an active. 10, I guess that's another active chip. 11. Oh, okay, so 9, 10, and 11 are the address. So they look like square waves, but what they're doing is they're actually counting in binary to activate the different gates to go through 0 to 8. So that's 9, 10, 11. 12 is another fader. 9, 10, 11, 12. Is that you? It's you. And that's looking stable. You know, it's not suddenly dropping out and being scratchy. What pin was that? That was 12. Whoop. 13, 16, 15, 14, 13. Now, which one could this be? What's this? What? Wait, why does it do weird? Hold on a minute. 16, 15, 14, 13. Why is that jumping around? As I... God, this thing's hard to... Hold on a second. Do 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 do. 16, 15, 14, 13. Damn it! These things are hard to... 16, 15, 14, 13. This knob might be bad, but I need a good way to test it. I need to stay stable on this and not bend the circuit board and simultaneously move the knob smoothly through its range of motion. Look at that. It suddenly jumps down. That seems broken to me. Look at this. Look at how I move it and where the voltage level goes. And then it skips down. And then that suddenly skips around. What is that about? Sure as hell ain't logarithmic. Lurk while I keep trying to work out AutoCAD electrical. That sounds fascinating. I've never used that tool. That one's weird. What is that one? Resonance. Oh, is that the skill knob? This is how you sound like you know what you're doing? And then the D-beam is how you sound like Carl Cox. Which is just like modifying the tone over time. So that one is resonance. That one is labeled VR5A. It doesn't have any kind of a special symbol. It's hooked up in the exact same way as its buddies. And that's it. So that is a broken knob. That is a broken knob. Resonance. I may have an Alpine of this type. 10K, and then B is the type of knob, and this is sort of like baller knowledge. This is like weird stuff that I've only recently learned about this stuff, is that there's 3 different types of knobs, and one of them is logarithmic and the other is reverse logarithmic, and then the third one is linear. So a B, I don't know if it's A, B, I don't know how they're, hold on, potentiometer types. A, B, and C. You know, Flywing might know it better. This new security verification thing, often called a pot, potentiometer. If you ever worked with electronics, Arduino, blah, 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 serial application, Symbol explained. Pins, pin out, how it works. What about the types? Rotary, linear, blah, 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 blah. This is a little too basic. I was actually looking for the difference between logarithmic and linear, but I guess because these are feeding into a microcontroller, I'm going to guess that these are linear, which means that I probably have 5,000 of these things. I may opt to buy one, though. Yeah, they're not consistently used, and then the labeling of what pin is what isn't consistently used. It's very annoying when you're like pulling them into your CAD software and you're trying to get it in the right direction, but everything's all topsy-turvy. A is usually log, B is usually linear. Okay, but then C would be reverse logarithmic. So anyway, that's a broken potentiometer. We found one. Ladies and gentlemen, we got them. And so that was on resonance. Oh, nice easy Friday work, right? Just keep it light. Don't do anything too crazy. Don't use brain. Use multimeter. Pin 13. And that was the last one of that chip. Huh. So we vetted out the rest of them. Now we need to go to the next one, which is the same thing, but we're doing timing, accent, reverb, delay, EFX, etc. So let's go over to that one. This one is with click. Can I feel that? Oh yeah, that's there. Okay. I did. It's on there. I did it. Yeah. Resonance, 10 kilobyte. Thought. That one I could probably repair in-house just by unhooking the top and putting that on a different Alps bottom. Next. Okay, so we're looking at IC4. IC5. IC4, all the way over here. So 6, 7, and 8 for ground. Same deal. We just look to see the smooth action of the potentiometers. I see way more than 4. There may be a few more than IC4, yes. Okay. Pin 1, which is reverb. So I don't know where reverb is. There we are. Nice consistent action. I go from one side to the other. I don't see any sudden dropouts, unlike its buddy over in the other corner of the board. Okay, I'm getting little flits of itches on my leg. What's going on there? Let me move my legs a little bit. All right, pin 2, which is accent rate, which is none of these. There we go. Nice and smooth. 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 Okay, pin 3 is going to be everybody talking. Pin 4 is timing. Which one of y'all is timing? Timing. Timing? Do we even have it? Oh, there it is. Nice and smooth. Pin 5 is not a thing. What is pin 5? 3, 9, 11, 10, blah, 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 blah. 7, 8, and 6 are doing that. Pin 5, oh, and pin 5 is in fact something, and that would be accent rate. pin 5. Ah, shaky hand. This is why I need that manual pick and place now. There we go. Good, as smooth as good. Smooth and good and not shaky. Yeah, these are in good shape. All right, so now we go to pin 15, 14, 13, and 12. 15 is D. Oh, no, wait, 15 is reverb. Reverb? It's not these, it's bass boost and volume. Those are probably a little bit more analogically hooked up. Reverb. See, it feels like there aren't that many controls in this area. Reverb's not like way over here or something. No. Over here? No. No, it'll be in this area. So it's not that one. It's not that one. This one? This one. Is it even hooked up? This is the one that I think it would be. The hell is reverb? Wait a minute. I'm going crazy. Hold on, let me check the front panel. See, it says there reverb. That goes to pin 5. Portamento. Reverb. Oh, it's that one. Well, let's double check. Let's make sure we don't have a broken knob. You got to make sure that this doesn't short anything out. Reverb is broken, but in a unique way where we don't see noise, we just see nothing. Check its pins. One should be at 5 volts. The other one is ground. And then the middle one is our wiper, which is wiping. Pin 15. Dun, dun, dun. We have a problem on the board. Now it gets fascinating, kids. IC4 dead. It is possible that there's something in between the two. Could it be possible that it's actually shorting out because we have a literal piece of cardboard in between these two? That's also a possibility. Maybe I need to get something a little larger to isolate our two boards. Wait, was that 14 or 15? No, it's this one. Okay. It was pin 15, wasn't it? Hold on, let's double check. $15 is delay. Did we find 15? It was reverb on... Oh, reverb's... Wait, reverb's on pin 1. Reverb... Uh-huh. 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 What? What? Wait, what? Huh? Huh. All right, just to rule it out, I'm going to get a big piece of, like, plastic and put it in between these two, just to make sure that we are properly isolating our two things from one another. Let's jump over and check to see that I got a big slab of something non-conductive. Something vaguely 505 sized. That's too much. It's too big. What about... Where's all my stuff? Oh, you know what? I have stuff over here. Right next to the desk. Big old piece of foam. That's actually too big. This one's the right size. Oh, this is a slab of... No, that's not... I'm not going to use that. Piece of glass. What a 3D printer bed. That'll do. That'll do just fine. It's It's a little heavy though. I don't really want to hurt anything. Maybe I won't do that. This is also way too heavy. No, that's not it. That ain't it. I think our piece of cardboard is okay, hopefully. But I just want to make sure that we're not leaning on the board behind it and shorting it out. But we do have a little height from this, so I don't think we are. Oh, the cardboard's directly below it. So yeah, what did I hear? Clicking noises. I heard tick, tick. That made me a little nervous. All right, so oops, sorry. I would put this on the micro, but everything's so big. So pin 1 of this should give us the analog. Why'd you say it like that? You say it all weird. From here, we can see that that's smoothly, the knob itself is okay. That's doing just fine. But when I check the pin, which is pin 1, we get nothing. Good day to you, sir. So that one is dead. In between these two, I just see the capacitor. That's just going to give it a little debouncing. That seems to work just fine. Put that at like a mid voltage. And then the wire, or the trace itself, is on the other side. I see some stuff cut away here, but that's just going to make a beeline over to this pin. But when it gets here, nothing. Why is that suddenly clean? Why is it suddenly clean? It's supposed to be like crazy. Huh. That one's dead. What about... I clicked 10x, that's why. Yeah, see, now it's dirty. Dirty. At 10x, you can't see the trace, so... I don't know why they have that feature. Anyway, so yeah, there's that. Whoa. Is that me, or is that... No, I think that's me. That's me brushing against this ground right here. Okay, so pin 1 didn't come all the way back. Yeah, doesn't come back. And pin 1 is on reverb. Pin 15 goes to EFX. Where's EFX? 15 EFX, which is the one all the way on the right. I keep thinking that we're working on the microscope. Okay, 16, 15. This is EFX over here. Nothing. Okay. Check EFX itself. Okay. So pin 1, pin 15. Let's check 14. Pin 14, I don't know which one that goes to. This one? 14 goes to R. And the other one's labeled 1. What does that even mean? Which one is R? I know it ain't over here. It's the other side of the board. Oh, there it is. That's, I think, 1. Are we in pin 13? 15, 14, 13. Yeah, we're 16, 15, 14. We're on pin 14, which goes to 1. Yeah. No, 13 goes to 1. So 13 would be, this one is R? Which one is that? Okay, hold on. Okay, none of those. Which one is 1? Well, 1 would be channel 1, but apparently not. Am I getting crazy? What the? So VR 18 and 19 are these two, here and here, 18 and 19. And 18 is hooked up to pin, Oh, wait a minute, pin 13 is connected to pin 7, which is ground. So 16, 15, 14, 13, this is just ground. So pin 14 would be this one here, which is good. And then pin 13 connected to this one, which is also good. No weirdness going on here. Okay, so far so good. This last one, pin 15. Oh, pin 15 is okay. Okay, pin 15 is okay. Pin 15 has been absolved. So pin 1 going to here is still the problem. Yeah, no matter how I harass that pin, I'm not getting anything back. And pin 1 goes to reverb, which is what I'm currently moving back and forth, but I don't have any changes. Those are all, that's everybody. Wait, if we look at everybody, okay, that's too chaotic for me to make anything out. I can't tell. I need a clock line. What's up, Poopsie Doodle? Okay, so yeah, pin 1 messed up. Something is not getting back to the IC. Maybe the trace is scratched or something like that, but that analog level is not being translated. I want an MC505, but I also want an RC505. What the hell's an RC505? I am very ignorant of what exists out there in the musical landscape of devices. Just to check, I'm just going to check around and see if I'm just getting confused about pins and outputs. Doesn't look like I am. Wait a minute. Oh, there that is. That is there. And it's fine. Wait, am I... maybe I'm just the crazy one and I've been looking at the wrong pins. But pin 1 goes here. Where does this one go? There it is. Okay, I'm just crazy. This thing works perfectly fine. The looper that Reggie Watts uses, the most famous one I could think of. Man, I don't even know. Who's Reggie Watts? I don't even... I feel so ignorant. I don't know nothing. Look at how clean the ground is when it's not hooked up. It's because this thing is plugged in over here, right? It's plugged in over there. And that strip, I think, is plugged into a different phase. And so there's like a weird ground loops between the two. I don't know why it's just so nasty and dirty. Also, the scope is going into this power supply right here. I think I'd probably need to bring in a more expensive and better filtered power supply, just so things are a little bit more stable from my scope. These are really bothering me. They just like light up the instant I hit the button. Reginald Lucien Frank Roger Watts is an American comedian, musician, and actor. His improvised musical sets are created only using his voice, a keyboard, and his looping machine. He refers to himself as disinformationist, who aims to disorient his audience in a comedic fashion. Whenever somebody cuts and pastes Wikipedia into the chat, I like reading it like the Mass Effect computer. I wasn't totally prepared to do it there. I needed to use a little bit deeper voice stuff, but when you read it, you're completely unaware of where the sentence is going. And so it's fun to add all those weird little accents to what you're saying. He's a ball of music pretending to be a beautiful man. I see. Scope for scope things. Yeah, we're looking at all the potentiometers and buttons and stuff. So we are observing what the signals look like and making sure that they're coming in clean, which in some cases they're not, but it looks like that IC was completely working. We vetted out, I think, every single piece of analog stuff in this area. So my assessment of pin 1 is not correct. We still have a 10K pot though over here that's not functioning. This one up here in the corner is giving us madness, whereas none of the other pots have exerted this behavior. If we hook directly up to the pot, we're using a ground that's like super far away, but whatever. You can see it jump around as I smoothly go from one end to the other. So this definitely had issues. So we have one potentiometer that we can fix. 60 hertz antenna, I know. Donk. Bad ground. Bad ground, dude. Bad ground. Okay, so that's all the analog things. We've vetted them all out. It looks like they're doing okay. We need to now look at button matrices. Button matrices. Metricities. Okay, we've looked at the keypad. We know which ones work there. Basically, they all need to be replaced. So now we need to look at the buttons. And boy, howdy, do we have a lot going on here. We have LED matrices and we have button matrices. Are these being done in the same way where... Yeah, they're being done in the same way as the keypad. Actually, no. This is being muxed. They're muxing through the rows. Oh boy. What the fuck? Wait a minute, what are they doing? Oh my god. I guess they're scanning through the keypad, but they're also activating the LEDs that are associated with the different rows and columns. That's not quite what's going on here. LED data. Sheesh. Yeah, they've got a big bus of columns and they've got their rows being activated by, I guess, muxes. Muxes or counters, I'm not sure. And they'll scan through and, yeah, do all that stuff. Wow. Okay. So we want to look at the switches. So I guess our best bet is to look at the columns. So we're going to look here on IC8, which is the 74HC547. D and Q, I guess, is the... But we're going to look through D765, blah, 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 and look at our various buttons associated. So I guess we want to go down each row. So I'm gonna get another clip. This will be easier if we have another clip for this. So we're gonna clip to D7 to 0, and we'll test the 8 buttons that are actually, how many columns? Yeah, 9, 8. They don't zero index. So we test each row or each column of 8 buttons that are associated with that pin to make sure that we see a clean signal coming out of it. So we have our ground clip. And we're looking at probably IC9, IC8, I was close. And I'm gonna clip to pin 10. See if we can get this on camera. Yeah, this is meticulous troubleshooting. Looks like I can't get it on camera. All right, we'll go from here. This is the problem with working on late 90s. Well, I could say it was designed in the early 90s. No, it was probably designed in the late 90s. Okay, so pin 10. So 9 pins, pin 10. We are IC8. This is 9. There's pin 10. Bum, 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 bum. Would you guys back up a little bit? Yellow clip in action. And then I need a jumper that is, well, I had these jumpers that were nice and loose. They were very easy to like clip to and stuff, and so they didn't like unseat themselves very easily. The wires were very flexible. The evil board. This one's not so bad. I've had worse. Scope hat. You gotta watch these things, man. You gotta keep your scope hats in a particular place or else they walk. They'll disappear on you. Okay, clip to you. And now we want to look at our first row, which is pin 9. What's right here? That's a little chaotic. It just keeps going and going. So in this chaos, we should be able to see the line go low or high. I don't know which one it's going to be from the buttons that I press. Why are all of these wired up together? Wait a minute. Oh yeah, no, they're supposed to be. So 7. Problem is, if the first button we choose doesn't work, and I don't see the signal do anything. Oh yeah, that song, yeah. I don't think I'm going to be able to observe them go low on this. I don't know if that's actually going to be a possibility right now, because the signal coming in is sporadic enough, and I don't have. I think we need to bring channel 2 into the mix here. Let's bring channel 2 in because we need a clock. I need some kind of a clock signal to go off of, at least for my start bit of this whole nonsense that's going on. It means I need to find another clip. A third clip has entered the chat. Yes, let's just rearrange where the Stream Deck is and push the AC wire around. Surely nothing bad can happen. Be thankful this is an original TR-808 you're working on. Those were built on a special bunch of transistors that failed to meet spec. They were saved from a recycling plant. What? By the guy who started Roland. Each unit was hand-tuned. They're basically not repairable because the parts they made... Oh my god. Yeah, that sounds terrible. Let me get a longer wire for this one. And then we need a third clip. I know there are equivalent parts for a lot of this stuff out there now. And they actually, some of the original modular synthesizer chips, the ones that are like Cool Audio and stuff like that, they've been given permission to manufacture them by the estate of the guy who died and no longer made them. All right, there's chaos. Why does that look cleaner? Why does it suddenly look cleaner? It was like really dirty before, and now it's like super clean. Did bringing channel 2 into the mix do something to it? Why? Weird. Weird. Okay, so let's get another clip here. I think I have another one of those micro ones. Oh, if I do, I don't know where it is. Let's check the other clip bin. I have another bin full of these things. It might be in here. Why would you have 2 bins? Listen, I don't ask you questions. Don't ask me questions. There's not one in here. There was a white clip somewhere. I know I got 3 of these things. Lord on the nose where it went though. Ain't there. All right. It might be on the top shelf or in some of the interstitial space. The 808 noise is a special fuzzy pop. Huh. I got a special fuzzy pop for you. All right, so we have to use this one. These pop off fairly easily. These are easy hook. They have just a little pincy thing that comes out. Sun farts? What are you talking about in my chat? Chat. You've gone off topic for the last time. Zap. That's fine. Okay, so where, if you were a stabilization signal, maybe a most significant or even a least significant bit, where would you be hiding? Well, if I were the number 8, I would be coming in, damn it, well, A, B, and C, we want to stabilize on C because that should only go high on the number 8. So pin 3 of IC5 of IC Wiener. Oh, that's not helpful. Which one of you are IC Wiener? That's IC4, 7, 6. IC5 is way the hell over here. That's IC5. Why are you over here? Why are you not closer to the... Double check. IC5, pin 3. Locked and loaded, boys. Damn it. See, that one just falls out. It's not fun. Actually, I think it's this jumper. I think I need a different one of these jumpers. Different jumper will do us well. We'll use this one. This one's newer. This is like another task. Another task of me just doing like the boringest thing in the world and going through all of my wires to make sure the good ones are in there. You do enough of this stuff and these tasks become a thing. All right, pin 3. Trick here is doing this without shorting out any of the subsequent pins. Okay. Now that should be giving us a stable frame, so let's move our trigger over to it. Channel 2. Yeah, rising edge should be fine. Okay. Now it looks a little hinky, doesn't it? Why is it glitching out? Stop it. Stop glitching out. Okay. So, what do you do for a living? Yeah, you're looking at it. But we try to make it fun. 7, 6, 5, 4, 3, 2, 1, and R. I don't know where R is. Yeah, it's much easier to interpret what the hell's going on here. Can I just get this in one image? That just give me one big image of the front panel somewhere. See, they split it into 2 pages. Maybe if we do our view in... How do I change it to page view? Now, yeah, see, this is like, where's that control? Take a photo, edit it. I'm trying to view 2 pages at once so that this is a coherent image, because they split it in the middle, and I'm using this image to find where all the stuff is, because if I uproot the front panel right now, all the little plastic buttons are going to fall out. So I would like to view both of these at once so that I know where the stuff on the... hold on, MC505 front panel. Just do one of these. There we go, that's all I need. And then, of course, I have to click through 500 different things in order to find that one image. Okay, there. Let's just make that its own window. And now I can move that somewhere else so I can actually find where all these controls are. That is an infernal link. Okay, anyway, it's just me not knowing how... Boomer doesn't know how to open a PDF. So with the 7654321 buttons are these guys right here. So let's see what happens when we press them. Why did that... It's like I see the one that's going low, but why are they like rearranging? Why does that signal change so significantly? This is not helpful. This is not helpful at all. Oh boy. Boy, oh boy. Maybe C was not the right choice. Yeah, this should be pretty isolated. I think it's just that the thing is becoming like rearranged. I don't know. Okay, hold on. Let's we don't need these data sheets open. Why do you do this? Okay, 5.5 group box. There we go. We got that. And then we were on C. A is going to be the least significant digit, isn't it? The magic of an old school step sequencer. This isn't the sequencing that's going on. This is iterating through a matrix keypad. This thing is not as analog as I would like it to be. It would be nice if this was more like the 303 or something, but this is a digital workstation for, you know, groove boxing. I don't know. I don't even think it has the diode ladder cutoff filter that the 303 has. I should bring back those MC303s, the panel mount ones, because we should take another stab at fixing those. G2B, G2A, and then we have A, B, and C. So pin 1 is A. A is going to go high and low a lot, and then it's also going to slip out because this is my worst easy hook clip. That does not seem to be the right frequency, Kenneth. What is the frequency, Kenneth? 7 is the last one of these. Hitting the button seems to do nothing. Perhaps I misjudged you. Maybe we should go on pin 7 just for our first... when our first column is actually activated, and then we'll be able to see that go high. How many pins is this thing? 8? What the? This is weird. This is very weird. Okay, so is that active low? If that goes low... Oh, yeah, the diodes are facing that way. Oh, hold on a minute. So this is iterating through, and then its common pin is what's being scanned. So that is actually where we should be looking for our rows and not our columns. This is activating columns, and I guess isolating us from the LEDs. That's the LED sync. What the And remind myself what this thing even is. Ah, I hate that space. Okay. Dude. Why does it have a flip-flop? Why are we flip-flopping? I expected weird. This is made when Ikutaro Kakehashi. Is that Kakahashi? No, it's Kakehashi. I see. Okay. I would assume that those are pronounced differently. I don't remember my kanji. What things make the sounds. Was still on their lead engineer on every Roland project. You should expect weird stuff. We already found our first weird, and that was yesterday when we were looking at the keypad, because the way that the keypad is iterated through, they have this bus transceiver in the middle of it, and it's like, why is that there? And the bus transceiver can actually be damaged if the microcontroller asserts something on it. So what they're doing is they're turning off this bus transceiver. But when you hit a button, when you hit one of the keys on the keys section, that's all the soft touch ones down here, what it does is it actually activates a line that the bus transceiver then will activate over here, and it will activate a transistor that'll turn on that particular LED when it gets scanned through on its 3 scanning lines. So the 3 scanning lines will scan through the buttons, and so if you're pressing a button at the time, that will then activate the same row and column LED, and then the microcontroller will see whether or not you're pressing the button. If you're not pressing the button, it will turn off this controller, and then no longer will voltage roll over to here, but it will still roll over to the LEDs if they want it to, if you want to externally trigger it. But they have to turn off this IC, or else you can damage the IC. It's like, why are you doing it like this? This is madness. So anyway, we're looking at the button columns, and it looks like we are switching ground to them so that, well, actually, what are we switching? Yeah, we're switching so that if we activate it here, we would see it on the common here when we get to a particular row or column count. It would do it fast enough not to flicker. Yeah, that's the thing about it. I don't know how you control LED brightness by doing that. I guess maybe you iterate through faster, slower. It's a mad scheme. There's a lot of mad scheming going on here. And then assuming, you know, the microcontroller probably was not programmed in C. Oh, look, they have 2 lines on top of each other. Whoops. Oopsie doopsie. Oopsie poopsie. We made a doopsie. Somebody moved something and it went on top of itself. Whoopsie daisy. So I was looking over here, maybe, because we're hooked into D7. That may be the wrong place to look. Because as that is powering up these, it's looking to see them get activated on scan. So we actually need to move ourselves from this IC. So IC 8 is not the one. We want to be on 5. So let's go over to 5. I think we can check all these buttons from over here. I was turned around because, again, this is a mad Japanese schematic from, and I assume because the chat member said that was Poopsie Doodle apparently knows this stuff, but Kakehashi Ikutaro. Oh man, Listexia is a hell of a drug. All right, let's get back on this IC and let's actually observe some of this stuff. Got some blue? What? Huh? Why would I blue? Good thing there's a potentiometer right here to get in the way. You're doing better than I could saying those names. I'm usually better about that stuff. I should actually take a Japanese class. There's what I should sign up for at my community college. Oh man, and then you guys, I'd let you guys select which body pillow I bring into each class. Oh my God, and I'd have to wear a fedora. All right, pin 8. Ground. So This is a 16-pin chip, and they've got little labels on the outside. It's very merciful of them to do that. I'm going to try to clip this so that there's plastic touching the pin next to it. Okay, that idea light just scared the shit out of me. That's literally like right here. That scared me. I thought I was blowing up like the Blue Origin rocket. Great idea. The teacher will surely love that. Yes, that will get me in their good graces. So 8, pin 9. So pin 8 is actually here, which is great. That's a great place. But I do see a decoupling capacitor right here. So I'm actually going to hook up to that. That'll give me a ground. Hopefully not a terrible ground. Oh wait, that's not ground. Oh yeah, that's ground. That's ground. That's what I want. It'd be nice if I could save the clips by actually clipping the alligator clip to ground, but I don't see anything available. I also have one of those things that you can clip onto the chip itself and it breaks out all the pins, but Mr. Kakahashi is largely responsible for the sounds of the 80s and much, much more. His little music company made some waves. I would assume so. That sounds really cool. Does idea make sound? No, it doesn't. It's just the light bulb is like in my face right now. It's a big thing in my peripheral view. So scan 1, pin 15. Ah. Nope. Pin 15. Our ground slipped off. So S-scan 1. And that goes to 7 others card exit wave select octave D-beam select and D-beam on. This one might actually be a problem because D-beam on we didn't get a button press from. And you can see here it's not really coming in. So I want to look at C, which is, where's my clip? C is for clip. C is for reload clip. D is for get down. So that's crouch. This is how I assign my shooting games. Am I the only one hearing 60 hertz, something on the audio? Whenever I touch to a ground, you'll probably hear that 60 hertz. Oh, you know, and also because these 2 plugs are right here. These are patch cables from the Focusrite. So those will probably give you a pretty good buzz. Try to get those out of the way. Like I said, my setup here is a giant ground loop. So we're having a little trouble with hums and stuff. One of these days I'll get to the bottom of it and fix it. Where did the clip go? Where did I had a clip, it was right here. Oh, there it is. Okay, so I want to look at one of the scanning lines, so C, B, or A. And I guess A's probably, well, C should be the least significant, or the most significant. But it's pins 1, 2, and 3. So let's just go to pin 1 first. Of course, that slips off. Of course it slips off. God damn it. I'm sick of these clips. These suck. Terrible. Okay. And then problem is this is moving that around, and when it moves around it unhooks itself from stuff. It's like experimental visuals. So this is the line going active. These these are very strangely clicky. See, I don't know. We're not getting anything like significant from these. I guess I can test at the switch to see if they're doing it. Because, like, this is madness. And I can't seem to confirm any of the positions on it. Others button? Where's that one? Others. What the hell's others? Oh, that's this one. So it's pin 7, others, and we're on pin 15. If we were on 14, it would be these. Would give us something, but these aren't really doing anything. So I don't know if we're clipped in right. Plus, this thing is blinking. Well, now it's blinking. Now it's solid. Blinking, solid. Blinking, solid. Blinking. Okay. Okay, yeah. So we're just not getting anything on that. I don't know if I'm clipped in correctly. We're seeing stuff happening. Stuff is definitely happening. Oh, Jesus Christ! Would you come on? Stupid thing. So, all right, let's not do that then, and let's just test them on an individual basis. Individual basis to see if the buttonings are buttoning. It's on, it's off, it's on, it's off. It's called blinking. Okay. Putting these away. What did I just open up there? What the hell is that? You get out of here. Been to, channel 2 off. Okay. That back on the pile. We'll go back to poking it. We still need our ground connection, but we'll go back to poking it instead of clipping to it. And then this is how we lose all of our clips, is by not putting them back when we're done with them. So I need to make sure to actually put my clips back in a bin, or else they walk, because they're good, and I should probably order a whole case of them. Actually, I just remembered where they all are. I got a whole bunch of them in the drawer. Oh well, they would have been useful then. Not anymore, because we're just going to poke our way through this. So at each of these, there's going to be a diode, and if I test it on the other side of the diode, I think we should be able to see if the button presses are clean. Because if we go to one side of it, we're going to see the whole bus, and on the other side of it, we'll just see the output from that switch. You can see that right here. So we see the output from that switch right there. So we're going to go from thing to thing, diode to diode, and we can see all these diodes all over the place. So I can just go around and just kind of test these to see what we see. Everybody online looking good. So like there is one side, and then the other side there is going to be the scanning that we see on the row. Why then, where's our output going? What the? Because like I don't see the high level here on the other side of the diode. That's where I should see it. What is this? I'm confusing myself. I'm getting hurt in my own confusion. It's like, how do I know if I hit the button? This button has a diode right here, and if I go to one side of the diode, I see nothing. I hit the button. There, I see madness. So without... My finger is very close to the ground collar on this thing. Oh, and then my ground slipped off. That's why there's madness. Where can I get a good ground? This technically should be a good ground, but I don't think it hooks in. There, if I did alligator... Well, now I can't move around. Okay, that didn't work. Let's see. Oh my God, people are... All right, let's see. So ground, where's a good ground? I mean, we clipped over here. That was a good ground. That one's nice and stable. Okay, so stable ground, other side of the button, and then we see scanning through the button. What? Wait, what's going on over here? I think it's intentionally blinking. We must have hit something weird. Okay, so I guess I'm just need an intern to hold the ground. I know, right? No, that was the most stable one we've gotten, was just by doing that. So now I'm just going to go around to all the buttons and just make sure that when I hit the button, I get sort of a mad square wave. I need to find a good way to test the other ones, though. See, that one I'm never going to see. It's this one. Ugh, it's very strange. Go there. I don't see anything. This is not as definitive as I would like it to be. But I don't think anything's wrong with these switches. It's just some of them, when I test it, see, I get madness. And I let go and it's gone. Madness, gone. This one, nothing. Oh, madness. Okay. So maybe I need to drill into these a little bit, get past that oxidation. That's not doing anything. And it is being activated, yes. And so on the other side, I should see, unless it's on me and not it. There was a little bit there. Ah, this is vexing. Like, okay, this one. Press. There it is. Unpress. This one. Press. Okay. Because that's it getting scanned like 500 billion times a second. I don't know why it's changing the rate of scan. That's very strange, but I guess what it's doing is it's connecting us to that line. But then why are we seeing positives? That's weird. Don't know what you're doing. Oh, you're for the transistor over here. Okay, this one. That one goes from, so maybe it goes in this direction. Nope. It seems like it's just smoothing out the end. The buttons are not S&D. I can't get to the pins. They're underneath. They're like tucked under the plastic. All I can do is test them at the diode, but these are being iterated through in a weirder way. I don't know what the hell. How do I know if a button is broken or not? Yeah, see, there's like oxidation on it too. So it's like, find the local diode, go up against it, twist a little bit to break the oxidation, test the button, look for a scanning signal. Unless that's not the one that I'm looking at. Should be. I feel like some of these are not in good shape. I saw a little bit there. Like, is it oxidation that I'm fighting? I think it is. Oh, this is maddening. Maybe we can use a test mode in order to do this. It's possible that we could use the test to take the test. I could, but doing the continuity on the multimeter is going to be very annoying because you need to find a good place to connect it, right? And I can't, I can't get to the back of the board. What test modes do we have? Oh my God, a lot of stuff. We'll have to hook back up the LCD, which is hot glued in place. That's kind of a tough one. Well, maybe we can put it back together and I can do the test mode. So but I need to actually check that the buttons are buttoning. Detest mode, Depeche mode, dun dun dun. LCD, DSP, sound test, AD test. debeam test, pedal test, encoder test. When switch and LED test ends normally, encoder test runs. So switch and LED test. Oh, I see. You have to go through these in order. Press all the buttons one by one, then each name of button appears on the display. This is pretty much what we want. Can I skip to a test? Before executing test mode, be sure to back up user data. MIDI cable, smart media, foot pedal, monitor speaker. Turn on power while holding down the D-beam button. What if your button doesn't work? D-beam and function at the same time and you go into test mode. As a rule, tests are in order of test number, but you can select each test item directly by pressing the keyboard pad 1 to 11. So I'd want to hit 4, but our buttons are fucked up. So I don't know if I'll be able to do that. Wait, it requires using the stuff that you're testing in order to run the test. This is a bunch of BS. Are the buttons just pulling the signal low? No, my friend, no they are not. Here's how the buttons are wired up. We have a direct schematic of the buttons, and it's madness. So the button is being activated by an LED sync that'll activate the row or column that it's on. We have a resistor going to 5 volts, so we're pulling it low. No, this will be activated by going low, but the arrow's going this way, so then this would be high when it's activated. So we have our columns being activated by going high with the LED sync line, and as they go high, we have this mux that is connecting them to the outside world and a resistor going low. So when we push the button, what the hell's happening? Test the test with the test. But if I can't test using the can't get, are you winning, bother? No. No, we stopped winning a minute ago when we switched over from the analogs to the digitals. I pretty much need to test all of the buttons to see which ones need to be replaced or if they need to be replaced at all. Some of them seem to be a little bit moody, as far as I can tell. And then I'm questioning whether or not putting it into test mode is actually going to help us, because it seems like it might not. Check continuity with the button with 5 volts without pushing them. Lionel, I don't think you know how complicated this shit is. I don't think you're quite grasping this with us here. This is all timed and stuff. If I test on one side of the switch versus the other, you can see what's going on. If I go and get a ground first, so I'll ground up here, just a clip that I know is good for it. And so if I look on one side of, well, it's one side of the diode versus the other. So one side of the diode, nothing's happening. That would be the end that's open. And then the one that's on the column looks like this. And if I hit the button, nothing changes. So I guess what it's doing is it's just activating that column when this thing goes low. So with that able to be switched to a low, if I push the button and the button's good and I've got good connection, I don't know which one is which. Things go crazy when you connect it. Because you're connecting to that scanning. And I've not been able to prove that to anybody. There, because it looks like that. And that's apparently scanning a bunch of the buttons, but we're connected to that as well. It's kind of fun watching you learn in real time why other companies had such a hard time trying to clone Roland gear. This is a whole bunch of syncs and timings, and you can do this. Like, I understand what's going on here. It's not terribly hard. It is not easy, though. It's too bad those small, precise probes they use for microelectronics industry are so expensive. They'd be really useful here. I mean, I guess so. Yeah, I suppose. Yeah, I mean, because I can't get to the leads for the buttons. So I can get to leads for the diodes, but they're typically kind of oxygenated. So like that button seems to work just fine. So I can test the buttons by doing this. I don't exactly understand what the hell's going on here. I mean, this is such a chaotic signal because it's also the signal that's coordinating what LEDs are turning on. And there's all kinds of LEDs turned on this thing. I mean, we've got, you know, end of phrase signals and stuff like that. So it's, you know, it's a little crazy. Like those green LEDs are on. That's what we're seeing on the other side of the buttons. Otherwise, it would be a nice flat signal, but they decided to also do LED control with everybody else, so that one works. That one works. That one works. That one works. These are nice and easy. That one works. 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 Okay. I'm getting a little bit better at understanding what's going on with these and why we're seeing the signals that we're seeing. It makes a bit more sense now. It's why it's kind of a little bit maddening, is because we are sharing a line with the lines that light up these LEDs. So the nature of that signal that we see when I hit the button will change depending on what the LEDs are doing. I could test this, you know, I could test this using like a multimeter, but where's the fun in that? Where's the fun? I'm probably instigating all kinds of weird modes to Psytrance 01 right now. Okay, those all work. All of our ice cube buttons are working just fine. Check this one. That works. What about our infamous non-working D-beam? That seems to work. Why is the D-beam so moody then? Yeah, see, this one doesn't appear. Wait, it changed D-beam modes. Oh, wait a minute. Oh, I see. Uh-oh. Yeah, when I click onto the diode, it was changing the D-beam mode. I was like touching stuff and it was... Oh, wait, that button works. Yeah, that button works. And you work too, right? Yeah, it works just fine. Okay, well, fascinating. All of our ice cube buttons work. Wait, we got 3 more to test. Hold on, these 3. Works. 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 Okay. All of those are checked. That just leaves the annoying ones. These little guys. I gotta press all of them and see if they function. Shall return with coffee. You better share. I just have seltzer. It's just hard enough that the people with the skills to copy it weren't interested in copying it. I mean, the parts that count were copied. We've got plenty of diode ladder. We call them diode ladder filters or transistor ladder filters. We've got those now, and that was a big Roland thing. It had a specific sound because of the components they used, and then we found that you can use different components to make one. You don't have to use matched diodes. You can use transistors, and the diodes, you use the transistors as diodes, and they are slightly cleaner. There's the signal. We should see 1 and 0 madness over here, but we don't. So this one might be a problem. octave button, dead. Now, we should double check these buttons. So what I'll do is I'm going to mark octave button on here. This one is fine. All this stuff is fine, but I'm going to mark the funky buttons here, and then we'll, I guess, come back with a multimeter and check them. So that's octave. Other ones in this area are okay. We're going to kind of move, let's move down. Let's go downwards on this. So we're going to slowly move our way down, checking each of these at the diode. And I'm going to try to get by the oxidation. It seems like the ones that, like, we checked the ice cubes and they're all fine. So I don't need to buy any of those. But like here, we're not getting anything. And then on the other side of it, we're definitely scanning it. So the problem is either the diode or the button. We'll have to check. And then that one is mode. Oh, well, that makes sense that it doesn't work. The mode button. Mud button. Mud butt. They didn't like my treatment of Harry Potter where instead of Mudblood, I called it Mud Butt. That one never got to the publisher, really. Nope, nothing from that. And then on the other side, we have the scan. Is it a bad button or is it a bad diode? That's my question. Because the button appears to be clicking, but we're not getting anything through it. So we're gonna have to take a look. Okay, so which one is that? That one is, well, mute control is this one. We saw mute control work, right? Yeah, mute control works. But this one is the part mixer button, which is SW28. I think a lot of these buttons are bad, or the diodes are bad. I'm not certain about that one yet. The multimeter will clear that up. Okay, that's that one. Did we check you? Yeah, that one was good. That one is the reverb delay EFX select. Okay, so moving through, we check you. Yeah, you work. So 38 and 39, write and undo repeat. Nothing? Are we scanning it? We are scanning it. Yeah, no write. Undo repeat works. So write. So we've been down almost all of these. We're getting over here. I should check. Yeah, this one we already checked. It doesn't work. Or my probe placement is bad. But I don't think that's it. Because we got a through-hole part, and if I just wedge it in there, it usually does pretty well. Part select. Okay, part select. I should probably just mark these on the image. That's going to make it a little easier, isn't it? Let's start up an MS Paint document. An MS Paint! Okay, so red, big red, octave. This is probably going to make it easier to accidentally... Wait, which was... This one didn't work, right? Or it did, but nothing changed. It seems like our sweepy stuff still... And I got those to change modes a bunch, but it didn't, like, stick. I don't know why. This one also works, right? Yeah. Yeah, we're just testing if they work, the buttons themselves. It appears that the damage to this unit was entirely because of wear and tear. This red is not showing up as much as I would like it to. Is that going to be visible? I guess. There's a lot of white on the thing already, but it's, I need a color that like stands out. Green means good though. And red just blends in too well. So we're just going to highlight them in white. That one's miffed. These apparently work, which is very strange. Mode does not work. Function works. SW28 is this one. Mute control works. Part select. Oh yeah, that's the one I just highlighted. Right doesn't work. Oh, part select is this one. Part mute. All right, that's the scan, and then we go to the other side of the diode, which we switch. That one's broken. Whether it's the diode or the switch is undetermined at this moment. Probes CN5 and the Y pins of IC5. It looks like a normal keypad scanner with a line encoder, but it's not, because it's also simultaneously hooked up to the LEDs. Although this one of them isn't. The keypad is. This one is a little different, but there's an LED scan that goes on, and then these hook up to a MUX. So you're saying I should hook up to CN5 and Y? CN5. Which, you mean C? Oh, and G2B? That's too many hookups. I don't know that many hookups. And we did try to look at these pins, and it's, I mean, we just see madness. Oh, the connector. We tried to hook up over here, but hooking up at the connector, I mean, look, we've already done it, and it's like madness. It's crazy. We get crazy go nuts stuff from it. If I hook up to pin, let's just, for instance, on IC8, if I go to D7, pin 9, and then if I hit R, well, we do see the one line go low. But now the madness comes when I try to hit the other buttons in that line. It's hard to tell which button I'm hitting. This would be a quicker way to do it, though. You're right. You're right. But we can't identify individual, because if I found a line that would stabilize it, which we tried doing with our other probe, I tried to find a line that would stabilize it. And it didn't appear to. You know, that appears to behave the way that I wanted it to now. I don't know what we got before, why it was so mad, which I guess if I went and did, if I hook up to, what pin am I looking for? I was looking up here at IC5, and I was hooked up to C with the other line. We could try doing that again, because it would be a faster way to test this. Actually, the way that I was doing it is fine. I'm going back to what I was doing, because we've made a lot of progress. There's a lot of buttons left to go, but it's not that big of a deal. So I'm going to go back to the way that I was doing it. You have a valid method, and it is what we tried to do, and it apparently produced madness. And maybe it is a more direct way, so I should probably look at it in that way. Yeah, damn it, you're right. You are right. You are correct. Fuck's sake. All right, let me go get my probes out again. I had it all out. It was all right here. I had it all. But this way is a more direct way to check if the buttons themselves are acting up on these lines. So it is a better way to do it, yes. I should be testing it that way, because that gives me sort of an idea of if that one is communicating all the way back. to where it should. Oh, let me get my more reliable, now that I remembered where they are. Hold on. These are not the good ones. Oh, I thought I had a whole set of the good ones. These are the slightly bad ones. Let's see if I can be relied on. Oh no, I guess it moved. I have my American nut roundener. And I had the anode and cathode labeled on it, but I don't know where it went. I think it got kicked around. I do have a sledgehammer that I keep right there. I don't know where it went. The emergency sledge. In case your electronics are acting up. Okay, so, according to the method of the chatter, Devil Builder, somebody with Builder in their name, I probably, oh, Binder, never mind, I thought it was Builder. Builder, I should automatically trust, but Binder, I'm not sure. Okay, I'm moving Paint over to the other monitor. Paint is now over here for me to mark down. And so we are going to hook up to C on this thing. And then we're hooking up to the... Why we're doing this is beyond me, but I guess we see the line go low on this IC. So we're looking at D7 to D0 here, but we're going to time it based on C, which is the least significant bit going into this mux, because that will be driving the lines high or low. I don't know which one it is, but we'll basically see a little march of all the 8 signals. And when we hit the button, that's one of the 8 that we're scanning, we'll see it go low. And if we do that, we can test most of the buttons in this thing, well, all of the buttons in this thing, directly at the IC, and we'll know if anything is wrong with the button or the diode or any part of that circuit. We've already discovered a couple buttons that have a problem, but I'm gonna hook up to this ground just because that's an easy hookup. It might be far away. I mean, Jesus, the wire is super long. It's gonna give us a bit of a doity signal, but we'll deal with a little bit of dirt. And then C will be connected to this one. C is on IC7. I'm sorry, going over here. IC5. IC Wiener. And that's pin 3. And then that slips out. Jeez. Okay, so that's a timing signal. I need to get my second probe back. I had all this stuff hooked up and I was working on it. It just gave me madness. I went circuit mad and wasn't getting the right signal. Whoa there, let's not involve the AC line, my friend. Oh, here comes that heartburn. Oh boy. That's going to be a bout. A boot. A bout of heartburn. Alright, so there's C. Hi, that looks like a classical switch matrix. It's not. A lot like a pinball machine. So if you have an entire row and column out of it, is it just random switches? It is an implementation of a classical matrix, but sometimes it does weird stuff. When I hit this button here, what that's doing is that's going into a bus transceiver, which allows for the... Look, man, you guys got to look at the circuit. I love learning that the orientation of my ground lead loop matters because of my proximity to one of the most powerful AM transmitters in this country. Oh my God. Oh, are you in Ohio where they have that giant submarine antenna that's like miles long? Very odd that you were getting that signal. You guys need to look at this schematic here. Here, you guys look at the schematic, because I don't have to prove nothing to you guys. I don't have to prove nothing. I don't need to prove to you guys that this thing is fucking bonkers. You look at it yourself. Start getting mad at Chad. Fuck you. Sorry. No, I shouldn't curse. I'm so sorry. I'm so sorry for the sensibilities of the... Oh, you're in the Chicago area? Gotcha. So we're going to look up here at the, whatever the hell this thing is, D7, pin 9 of IC8. And hopefully that will get us somewhere where I can hit buttons and we see ones and zeros flutter across the screen like dancing swans. Dance with us, Dib. Dance with us into oblivion. IC8, pin number 9. Right here. See, the thing is, I also have to be able to hit the buttons as we're going through. And this one doesn't do all of them. We're going to have to jump around to a couple here. Look at our little guys. Oh, they're so cute. Look at them. Okay, so 7, 6, 5. Weird. 4, 3, 2, 1. R. End of row. Next row is pin 8. So pin 8. That starts with, oh boy, where are we? Others? Where's my picture? It's all the way over here. Others. What the hell? Which one is others? Oh boy, we got to hunt around for this, the identity of this button. Others is also switch 53A. 4185. Where is it? Oh, others is here. Okay. And so we're going others hit Tom. Other people hit Tom. Symbol. Symbol. Clip CLP. Yeah, that's correct. And then I'm like scrolling the schematic that I've zoomed way in on. Where's my mouse? My mouse is all the way on the third screen. Okay, hold on. Sorry, I'm going crazy. So we were on clip double H SD double H SD BD. Okay, this is a lot more stable and easy for me to test because now we can actually see. Before we were getting like a mad signal in here, but I guess this is stabilized it much better. The next row is on pin, oh, it's the one that overlaps the other one. Well, pin 7, so we're 987654332. Okay, so that's not a crazy one. We just go across these guys. But, oh, what the hell's going on in this one? What is that? Why is that weird? Is it me? Okay, so maybe we chose like a cursed thing when we were looking through. That's weird. Oh, you know what it is? It's like that because it's controlling LEDs. It's controlling LEDs on the interim of this thing. Wait, no, that's not how this one works. That's not how this one works. This one doesn't control LEDs, so this is just madness. Maybe it is. Maybe it is controlling LEDs. It's just weird that there's like, I don't know. Well, anyway, so we are on 10987. So pin 7 starts with card. That's up here. See, this is where we weren't really able to see a nice clean button press because things would like shift around. But I guess when I hit card, certain lights are turning on. Not really. Pretty much nothing new is happening when I hit it. So why? Is it consistently the same signal? I guess that one over there is changing. I don't know why that would like shift around though. So card user, that's doing a thing. Card end user. What the heck? And then preset. then patch. Somebody is drilling something right now. Patch. No patch. Broken button. Okay, this is okay. This actually does work. For our individual button testing. So patch is not working. The next one in patch RPS set, which is, good God, you guys. RPS set is this one. That's doing something. I'm going to guess the next one over is the next one on our thing. Pattern song. Broken. Yep, nothing happening. Pattern song. I'm guessing PTN. Hold on, let me move these windows so that we can view more at once. So, pattern set is this one. Nothing. See, it's not, the whole column isn't dead because we still have, these guys still work. It's funny that we get like little clusters. The card button is also a bank selector. It doesn't matter. It doesn't matter what it's called. All we're looking for is a change in this signal if the button works. This is intermittent. Wait, now it's working. I hit it a couple times and now it works again. Now it doesn't. Now it does. Now it doesn't. So that one's intermittent. This is pattern set. Sometimes, and I think maybe it might be because I'm flexing the whole board, because we have the same issue with the with these guys up here, where they would like suddenly come back to life. You see here, I'm pushing the button. Oh, that's the wrong button. See, this one doesn't do anything. The one next to it sometimes does something. So that's like intermittent. And then tempo. Tempo dead. He dead. Tempo's dead. It's dead. It's just dead. Tempo's the end of the row. Next row. Next column, rather. With edit, and that's pin 6. Pin 5, are we in pin 6 right now? 10, 9, 8, 10, 9, 8, 7. So pin 6. There. So we're this one with starting with exit. All right, so let's move the probe. It's funny the ground for this is so far away. Probably should just hook up to this chip's ground. Probably could use a logic analyzer for this too. I wonder if it would fix the signal if the broken buttons are removed. Don't see why it would. That depends on the state of the broken buttons. I think the state of the broken buttons is an open circuit, so it's not going to affect my baby. Exit. Computer exit. Nothing, okay. Exit button, where the hell does that even start? Shift, edit, scale, mute, rhythm, tone, select, part, select. Exit. Exit, okay, that's all the way over here. While I'm doing this, I'm controlling stuff, but it doesn't matter because we're looking at it at like a system level. So exit button, dead. That one works. Just jiggle it. See, sometimes you start jiggling the buttons a little. They're probably like really worn inside. So exit is dead. Dead enough that I'm going to replace the button, basically. And we'll investigate closer to see if the button's definitely what's doing the badness. Enter would be the next one. Let's test enter. Give it a couple presses and just make sure it's consistent. I have to order a lot of these switches, it seems. Okay, that one works. Exit, enter, deck, decrease and increase. That's those two up there. Decrease, increase, decrease, increase. Hold on, this moved. Make sure it's not. No, it's fine. Decrease and increase. Yeah, rip menu navigation buttons, indeed. So deck, ink, and I'm guessing page right and left. Yeah, page right and left are the next two. So it's like all four of these are just dead. They're like, they intermittently work. And I don't know if it's the diodes or if it, we'll do a diode check with the multimeter. This is all multimeter stuff to check over once we have established that it's not changing any of the parameters. This one, that one actually works more consistently, but I find it difficult to get a 1 per press, so I'm just gonna replace the whole thing. The problem is, I don't know if it's me flexing the board that's actually getting these to work again. Like if it's a cracked PCB thing. At least we're going through these a little bit more systematically. Where were we? Page, scale and edit. I'm trying to move over without, okay, there we go. Scale and edit, where are you? Part select, tone, rhythm, mute. Wave select. That's envelope select. Portamento, no. Scale and edit. What button, what numbers were they? They were 63 and 66. 27, 45, 58, 59, 63 and 66. They're all the way over here. Oh, that's these two. Scale and edit. They were right there the whole time. So scale, edit, broken. I wonder if the fluorescent dyes used for detecting cracks in structural steel would work on a PCB. Probably not. No, because I mean, with a broken trace, it's just broken copper. They can be very difficult to see. Scale and edit do not work. You bastards, both of them dead. Scale and edit. Oops. This is a lot of switches that I have to buy. They must have spilled orange juice on this thing or something. All right, next pin down the line. My phone decided to buzz just when I... Okay, next one down the line. So wave select, which is way up here. Move this over a little bit more again. Wave select. Uh-huh. 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 Okay, wave select. Wave select. Dead. Who's next? Rundpan. What? Random pan? Randpan? Select is there. So, oh, random pan right there. Okay, that is actually written on the thing. Rand pan. Go. Dead. I'm wondering, so when we check it like this, we're checking to see that it is activating it. So we both see it trying to activate that individual button, and we see the button operating on the thing. So anything between these two could be the problem. And so it may stand to reason that the problem with the switch is that it goes across the entire PCB. Maybe there's a crack in the PCB, maybe there's a crack local to the pads of it, or maybe the diode is doing crack. I don't know which one it is. The next one down the line is select, isn't it? Bomb select, yeah, there we go, select. So we hit the select button and we see nothing happens still. Nothing has happened this entire time. I'm wondering if I'm on the right pin. Let us double check the pin, just because I haven't seen a single one of these work yet. So we are in wave select. Pin 5. Ten, 9, 8, 7, 6, 5. What the hell? Come on. Pin 5. Yeah, so these are just dead. I mean, that's the behavior that we were seeing from the unit anyway, is that these pins are not working. And it's not a matter of me being in a weird mode. What's up, Bat Your Fan? How you doing? Don't forget, it could be meth. It's true. Topo Chico mineral water is a great way to kill switches. Really? It ate half of the switches on my keyboard in less than 3 hours? Not a lot of environmental protection going on here, and mainly because that stuff costs money. So in newer designs, they found it to be cheaper to use things like domes, dome buttons that you can put an LED behind and still get it to light up just fine. And so you have this big rubbly interface for all of your soda to get into, instead of it getting onto the electronics and permanently ruining them. But yeah, we're not seeing anything from some of these buttons, so I don't think that's going to be, like, cracks on the circuit board maybe, but I don't really know if that's really going to be it. I think it's just old electronics. Okay, so going down that the same pin that we were on, we were looking at wave select, random pan select, LFO1. So select again, nothing happening. Which is fascinating because I thought we saw the signal on these. Didn't we check? No, I was wondering about these. That's what it was. This is where I started to test our methods, and this is where the most problems are. Well, that's my problem. Just to not go crazy. Wait. Is that just because it's changing? Why is that one changing it? What the fuck? Okay, weird stuff. It seems like this column is affecting the column next to it somehow. That's very strange. So, well, octave, what about octave button? That's like over here, isn't it? I think I might be hooked onto the wrong pin. That's what I'm trying to get at here. But we don't see it going low. We just see this like shifting over. I don't know. I don't like what I'm seeing. Looks like it's affecting the trimming of the CPU. Yeah, it's like something about an instruction that it stays in a little too long and it changes the timing, and that's why the wave appears to be moving down the line. It's just because one of these things is timed a little differently. Yeah, not trimming timing. I mid-sentence, I understood. Okay, so I'm looking for, like, it seems like this whole column is dead. Which could be a PCB issue, but let's just, if I can leave the hat behind, come over to here. Of course, then the wires get in the way and they ruin everything. And look at this side of this. Look at this side of this. There it is being activated. Yeah, but the button pushes is not showing me anything. Yep. Yuppers. So the activation signal is getting there, but the switch is dead. Yeah, okay, that's what's going on. Pretty definitive, huh? Where did you go? Oh, you're right here. I got a bunch of dead buttons. Just timming around. What is it? Huh? Okay. So I was going down this column. Wave select pan. Select is dead. LFO is that one all the way out there. This one. Nothing. Wow, that's the whole side of the board is like toast. That's so weird. Solo and portamento on. Whoa, that one wants to work, but it's, whoa, it's trying. It's trying. I have to really really wrench on it. That one kind of works, but it's a little weird. Yeah, like, see, I pressed it twice there and it didn't go off. Not every push is actually registering. That's so weird. These suck. These are both dead. This whole area, dead. Transpose and shift. That's over here. We're going all the way over here then. Do I flag the enter key as being broken? Some of these are like weird. Which one of y'all is transpose? Here's shift. Measure, tempo, stop, play, record. None of you are transpose? No. Transpose and shift we're looking for. Shift we know is over here, but transpose, where's that? That's part select, right, undo, redo. There we go. Transpose and select. So these two. So shift. Wrench on it. Nothing. And then transpose. See, almost that whole column was broken, which leads me to believe that something is wrong with the column. But then when I go to the individual diodes on it, we can see that the activation signal reaches all the way over there. So the whole column dying would be indicative of something happening on the switched line that pulls it up. But when we look at the line that pulls it up, it seems to be going all the way to the diode. Oh, man, it's confusing. Or the pulls it down, up, I forget. Anyway. This is madness. Okay, so those are all dead buttons. And we did see that some of them were intermittently activating. Like if I really push down on the button, it would eventually send a signal. That's this one. Yeah, here. If I wrench on it just right, you can see how it's kind of like half activating. That's just age. That's just oxidation inside of the thing getting to it. Or I don't think the metal of the dome might have worn away the metal that it clicks onto. Because these are just like little tactile switches. Oh man, this is gonna be expensive. This is a lot of buttons. I could just spend the $100 and get a new PCB for the whole thing. Nah, we'll do the individuals. It'll be fine. Okay, so next one, pin 4. We finally get to quantize this frequency. Oh, here's some madness again, too. Octave. We already know that one's bad. Octave. Yep, confirmed for bad. Quantize. Quantize. Bad. Skip. Part select. Part select. Is it this? Oh, this one, part select. Nada. I already know it's bad though. Tone select. Tone selector. Tone select is... Oh no, part select is here. We also know that that one's bad, so it doesn't do anything. Tone select is right below it. That one... Intermittent. Part select, trying again. Tone select, both. Yeah, see, it's a little bit hinky, so I'm gonna call it dead. Dead. If these are tactile switches, chances are they're simply done. Yeah, they're just like domes inside of them, but they've got plastic around it. Have you tried threatening with a hammer? Some of these seem to come back alive when you kind of force the issue. You go, hey, 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 and they go, fine, I'll press. Hold and RPS. Hold and RPS, so that's these two. Hold, a lesser used button in the grand scheme. Hold appears to be working just fine. RPS. Nothing. That's madness. Madness, I tell you. Of course, the hold LED isn't turning on either. Maybe there's nothing to hold. And RPS just doesn't do anything. Craziness. This thing is not in good shape. All right, next one. D-beam select. D-beam select. Now, I don't trust this one. Maybe I do. Yeah, that one seems okay. Why are the LEDs not doing anything anymore, though? Okay, D-beam select, fine. Arpeggiator on. Dead. We're sure we're on arpeggiator on? Yeah. This thing is not compact. This is a very large device. Dead. Okay, arpeggiator on is dead. Where were you when arpeggiator on was killed? Arpeggiator on ethics. That would be this one. Ethics. Dead. No! Dead. Man, it's like half of the buttons on this thing are toast. Just from age? Part the mute. Part mute. Whatever this one is. Rhythm mute. Part mute. Feel the rhythm. Feel the mute. Part mute. Rhythm mute. Right octave PTN call. So right we know is dead. Dead. Octave minus, dead. Huh. Right octave minus. PTN call. Pattern call. Dead. It feels like a lot of these columns are completely dead. I'm gonna go see if the garage is cool enough to hang out in. I want to go put on the 8-foot wide projector screen. You're gonna put, that's too big. It's too much. Too much responsibility. Okay, last one. So on to the pin 2. Basically, everything that the human interfaces with that wasn't a potentiometer is dead. Beam on. Wow, there's a lot of stuff going on in this one. The beam on is kind of like a difficult one to hit, but it does work, which is rare. I guess these little illuminated ones, they all seem to work just fine. Okay, beam on works. Mode, we know that one's dead. Nothing. I need to slide this over a little bit. Funk. Once again, these light up buttons are better than the tactile switches, huh? 7 select. What? Which one is that? 7 cell. Would that be mute control? Oh, and it does work. Switch 28. Hold on, which one is this? That's 23. 28's this one. Oh, that's the part mixer select, which is dead. Aha. Aha. Still dead. Mute control. Okay, yeah, so that's mute control. That works. Undo, redo. Dead. Octave plus. Dead. Dead. Where's hold? How's hold doing? Is it safe? Is hold safe? Is it okay? Where's hold? Right, octave, hold. Hold is on pin 4. Oh yeah, hold works. Who knew? Okay, so that's this matrix. That was messed up. There's a lot of dead stuff on this. Now, is that fully covering us? I don't think we did anything with the sequencer controls over here. So I think we have another matrix that we need to probe. Was this part of the keypad matrix? Might have been. The keypad matrix is kind of another animal. We should probably check up on that, though. It seems like the LEDs are okay. They're just very dim. And then our general matrix of all of the controls on here is just massively crazy. There's all kinds of weird stuff going on. All of the chiclet buttons, the ice cube buttons are fine. Those are all fine. It's just the other ones that seem to have had soda spilled on them or something. Damn, that was a lot. Okay, so there's that. Where else do we need to go? We need to look at LED matrix is okay. I guess I would need to find where that play button is. And we know all of our analogs are good. We checked them out. Except for one. The one all the way up in the corner. Oh yeah, measure, stop, play, and record are over here. And I think we clocked those as working. Let me just go through them individually. I don't know if we're gonna have the same timing or not. It's a slightly different setup on that. Yeah, these work a little differently. They're on a different timing. I think they all work though. I don't know if we have any problems with them. How did we hook up to those? Those were madness. Because like these I can check at the resistor, and then the timing for them I can get through the transistors, or, well, it has to be the transistors, I guess. But that's just for the row activation. Okay, I think I have all the information that I need. We know what works and what doesn't. The play, stop, and whatever buttons, those I think are fine. We tested those last time. I don't remember precisely what we did, but I do remember them as working. Because testing them against ground doesn't quite work. Although I could test them against 5 volts. Let's find a 5-volt signal and hook our ground up to that. No, that's a bad idea. That's a bad idea. I try to independently reference, and that can cause problems with the ground loops that I've gotten here. We've had that happen before. I find your findings hard to believe. Pop a def and take it apart. What does that mean? Pop a def? Pop a meat? All right, how many switches is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 20, I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 7, 28, 29, 30, 31, 32, 33. I need 34 buttons, so probably 40 buttons. And make sure that this gets archived. (50534) BTN REPL. I'm going to put that on the desktop. Pop a defective one and take it apart. Yeah, let's do that. We need to test it independently anyway, so let's turn off the 505. And I can quickly take one of these out. Although inverting the 505, getting the other side of this board is kind of difficult because I've got connectors on, like, every edge has connectors, so it's kind of hard for me to get in there. Need to do it anyway. It's part of the process we're in. Make sure that the scope hats go away properly. Those are very important. Those things are made with gold. They're pure gold. They're heavier. They exist in 4 dimensions. They have a mind of their own, and they will walk away if you're not careful. I used to have my own set because you can buy extras. I had my own set at my job so that I wouldn't lose these things. So in my own shop, I am very careful about keeping everything together like this. Okay, have we had time to discharge? Maybe we'll just isolate out that giant big ass capacitor. Go. Okay, so this entire corner is dead switches, so let's get some of these out of here. We can just get them right out of here. The question is whether or not a feed to the switch is broken, if it's like a broken trace. And I don't think that's the case. So look at where the heat is on this. This is after being on for a couple hours. These op amps are quite toasty for some reason. Why are they so toasty? They're probably driving stuff. Obviously the processor is hot. There's just so much stuff on this board. Yeah, I really don't think it's broken traces, but these are kind of out at the extremes of the board. I mean, everybody looks healthy here. If there were a crack, it would be right up against the edge. And we saw the back. We saw the, what do you call it? We saw the signal at the other side of these pins. So they're not broken. If the diode is diode, that's the other question. Let's check the diode to see if it's diode. These little glass diodes, I guess, can be fragile sometimes. So this is where I'm actually using the diode mode of my multimeter. I rarely ever use the diode mode. You guys can't really see that. There's no light on it. The diodes are fine. They're all just fine. They're all dioding, doing their best every day, giving it their all. It is the mechanical buttons that are the problem. As predicted. So, can we get away with using the solder sticker on these guys? The button is, let's see, the button's the lower one. This is the diode, this is the button, this is the LED. This is the steeple, this is the church. Yeah, those are gonna have to be bent. They did the aggravating method of bending the leads in order to hold the part in position. No one expects the Spanish in position. Smell of flux in the morning. Actually, it's deep into the afternoon here, but who's counting? I think they're plated through. I don't think they saved money on that. What's up, Coaster Facts? What information do you have about commonly asked questions for coasters? That guy's got all the information. What are we soldering? This is a Roland MC 505 from 1998 at most. I don't know. We didn't find a date code on this. I don't know where you find the date code. We can probably find it in the software, but Wear and Tear has claimed most of the functionality of this board. It seems as though it's not, for instance, a flexed PCB or anything like that. It's not those common issues like that. It seems like these buttons are just worn out. So, let's get a little closer. I'm going to move the electronics over, keep them safe somewhere. This is this is one of the biggest PCBs that I've ever had in the shop. Sorry, I'm like hiccuping little bits. I had the other half of that cheesesteak for lunch, and it was delicious. I put it in the toaster oven under broil, and broiled the hell out of it. And it was delicious, but now I am paying for my transgressions, my food crimes of putting ketchup on a cheesesteak with heartburn. All right, there we go. We're much closer. I'm moving it up closer so we get a better view of what's all here. Where are my tweezers? There. Okay. I can't shake the desk when I'm... Jeez, stabilize, stabilize, stabilize. So, this is our button. It supposedly is dead. If I put the multimeter on the leads in... I'm not using beeps, I'm using ohms. Ohms gives you more information. You want that extra information when you're trying to find out what's wrong with something. These are going to be hard to go on. Yeah, this is going to be like impossible. Here, let's use the big ends. So when I press it, it goes down to kilo-ohms. I know that's hard for you guys to see. I'm a certified ETA journeyman on the side. I'm also knowledgeable about electrical engineering. Well, welcome in, welcome in. Welcome in, welcome in. My credentials are below. I've been streaming since 2016. Was it 2016? I don't remember. All right, so ohms mode is the mode that we like to live in because beep mode is a crutch. Beep mode is specifically for diodes, or if your vision is obscured, if you can't view the multimeter. What ohms mode tells us when we're probing around circuits is, you know, how many ohms are between our probes. So if we go on either side of a resistor, we can see that. Or if we've got like a long trace, we can see that the trace is actually long, and that's what's affecting it. Or if we have something like this that's a little dodgy, we get more than just a beep. Like that might set off the beep, but what's really happening is when I press this thing, we're getting a lot of intermittent values on this. The button should be more consistent. It should be, when you press it, it'll go to very low ohms. It'll be like tens of ohms. And that's just the resistance of the scope leads. So yeah, with the big leads, it's through-hole stuff is a little easier with the big leads. I can just kind of put a little outward pressure on this to make decent contact. And then if I push down on the button, we can see it going to 100 kilo-ohms, which is not acceptable here. Found you through the Djibouti boys. Oh, that's cool. We've got a lot of UO's Lab people, a lot of slabs in here too, because UO's Lab did like a 400-person raid, which is insane, but then everybody goes, this stuff is boring, and they just click away. So right now we're trying to fix a Roland MC 505 groove box, which is kind of a little bit of a digital instead of an analog. So we've got a lot of buttons and levers and inputs and stuff. But this is the shop where I do all of my streaming. My claim to fame was the board back there. We're going to work on that soon. I keep promising it and never working on it. But I'm trying to clear off some little projects so that I can get to that board, because that board was a big mainstay of the channel. If you subscribed, it would burn the name of the subscriber or the giftee onto itself, a big block of wood, using a blue laser, a 4-watt blue laser that's being underrun, because you can't, all you can find are these DSP and projector lasers, because they found out that if you make a laser hit a phosphor, it'll create yellow light. And so yellow being the red and the green component of RG and B. So you take your blue light, you make your other two frequencies of light, and then you put it all together, and you have a really high quality, very cheap light bulb for a projector, which is why that's all you can find. You can only find blue lasers, but blue lasers have an ultraviolet component, which makes them hot. And so that heat is what we're focusing in on with the laser and making it burn names onto a block of wood. I have 2 big slabs of wood, and one of them is filled with, I think, 1,600 names, and then the second one is filled with 5,000 names. So these are put together by just simply squishing plastic on top. It's literally just a piece of plastic and then a domed piece of metal that you push and it snaps over. The thermal camera is there because I do soldering, and soldering involves heat, and also troubleshooting electronics involves heat. Heat is just integral to the whole process here. And so I bought this cheap Lepton thermal imager, and a place called GroupGets does a, what do you call it? A webcam module for it. And we 3D printed an enclosure for the whole thing. I had to design that in AutoCAD. Fusion 360. Have you ever farted on the heat cam? I've seen those GIFs, those like, hee hee ha ha, look at the fireman farting on the cam, and you can see this beam coming out of him. Except that the beam is green, and there's no green on the Lepton thermal imager. This is a copyrighted set of colors for Lepton Incorporated. And so when you see something that looks like this, you know it's Lepton, and if you see green, you know that they're faking it. So the 3 cats sitting on a bed and one of them farts, that's fake. It's a little fart insert like video insert that they made monochromatic green because ha ha he he, funny green fart. The one with the fireman doing it, and there's this big cloud behind him. Hoo 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 ha ha he he fart. Nope, that's fake. They were using a CO2 fire extinguisher that he had between his legs because you will not be able to see a cloud like that. The human body does not eject gas on that scale. And that gas would be body temperature, but you probably wouldn't be able to see long wave infrared from it. It would dissipate pretty quickly. I have not farted on camera. That would be a fascinating test though. Although whenever my butt is visible, people do set off the channel point fart machine. We've been working quite a bit for interactivity of the people viewing, and one of those interactivity things is channel points. And so I very just basically hooked up channel points to a dollar store fart noise maker that just so happened to hook up to a Harman Kardon speaker and do a lot of good. It actually is very, very loud. Where did that go? It's gone. So how does this work? There's, I guess, a component that clicks over here. And that's what this dirty thing is. That's the part that was making contact. Whoa. Yeah, it's old. I wonder if I just clean that up and put it all back in, if it'll work again. Because basically it just smashes that down on these two contacts. And that's what's gotten worn out. You can see it's like just discolored and weird. And then here's the big dome. Just here for mechanical purposes. Because they still make the signature snap. So if I push down on that, it's still, well, I can't really, it doesn't really snap over definitively. Could you make Batman gadgets? I've been watching people play that Bond game, and they all have all these wonderful yeah, there we go. That's getting that click. They all have these wonderful gadgets that are like amazing. And it's like, could you build Bond gadgets like that? And it's like, yeah, like how much money do you have? Because you know what you can do these days? You can just Venmo Carl in accounting and figure out everything you need to know about your foreign adversarial. You do not need to give somebody a $7 million watch with experimental technology in it. You don't need that. You don't need to pay rent on an underground facility. You can just Venmo somebody a little bit of cash and find out what they're doing. Like it's not that hard, and all of the spies are the most boring people because they blend in. So that guy over there pointing his Rolex at the computer with a little beam coming out of it, that's probably not a spy. The spy is going to be the guy who does your accounting at the end of the day. These new guys are rowdy. That's fun. All right. I fart on every camera I can reach with my fart cannon. All right, so I'm in it. I'm in it for ordering a bunch of parts. We need 16 of the special switches. We need an AB encoder. We need a 10 kilobyte, a 10 kilo ohm B-type potentiometer. I might actually have that. And then I need 34 of the buttons. That's so many. That's just a cringe 007 fan. I mean, you know, like 007 is all about the gadgets and stuff. That's a lot of fun. Could I build 007 gadgets? Probably not, because most of them don't actually exist in reality. There's physics. Physics is a little pesky for the types of stuff that we do here. Physics can seem to get in the way quite a bit. And then also, people overvaluing the skills that I have happens quite a bit too, where people think that I can build a rocket ship, and I'm an engineer. Of course I could, but then again, that's also overstretching my own abilities to design and implement things. Man, this is nice, really nice that we have just an extensive schematic of all this stuff. The older equipment from like the 90s and stuff, it's very nice that they still give us all this information about it. I say that you could build your own Pip-Boy 3000. Yeah, but the problem is I would get so distracted trying to make it out of a real like vacuum tube display. I'd want it to have that signature look and feel, which again, since it's a game, obviously they don't have to work with real high voltage and vacuum tubes to make things like that. So the design of it is different. Actually, no, it's not just like balls. I know the level of humor you want is like balls exploding, but in that game, you literally have a poop dart. You hit them with a dart and you go, oops, you got to poop. And they go, oh dear. So you can really exist on that level in the Bond game. All right, let's see how much this is going to cost. Oh, that was that was a totally different browser window. Hold on. You could make something wirelessly that fries electronics in this specific cone like 5 degrees. They actually do that with explosives. When you have an explosive going off, if you put a piezoelectric element, because remember, piezoelectric, it makes those beepers beep, the beepers that I hate. I hate beepers. I've been diabetic since I'm 9 years old, which is a like couple decades now. 4. But anyway, I've been diabetic for 31 years. Things that beep immediately get my attention. Can't stand them. Can't stand them. If something makes a beep, no, I will kill you. I hate the beeping. So I disable a lot of these little piezo beepers, but piezoelectric elements, when you hit them with energy, they create electricity. It's like a weird crystal thing. So if you have a piezo element, and I don't know anything about the design of this, but if you have it in the path of an explosive, then it creates a whole lot of energy. And if you make a cone of wire, that cone will collapse in such a way as to create a sliding length antenna. It gets shorter and shorter and shorter while the piezo element's putting all this energy into it. So that's how you make an EMP. It goes off once because it explodes. So whatever you've created no longer works. That's what those EMPs are when they have one sitting over a car and they're like, look, this car is running. And they go, oh, it stopped because we set off the EMP. It's happening inside of the EMP. It's explosive. That's how a lot of these like EMP missiles and stuff work too. And that's all surface level Wikipedia stuff. So don't come at me about sharing government shit. Surface level Wikipedia. The other way is EMP is to do a little spark gap. But again, like, bother, can you make an EMP? Yeah, I'm not going to do it because I'm a type 1 diabetic and my pancreas is literally, my pancreas is literally transmitting information electronically that we can view online in real time. So yeah, what you do, so if you want to make an EMP, what you do is you set off an explosive that boils water and turns a turbine. All right, let's see here. So we've got, those are the bad parts. We have, where did that page go? Where did that page go? Wait a minute. It was on this page. No, I don't do anything like that. I don't do that kind of stuff. We could get the entire PCB of the thing that's been pissing us off for $90, which is not that much, all things considered. That's really not that bad. So we need 16 of these shits. I don't want to check, I just want to add it to the cart. Oh, it's already $50. Come on, man. We don't need any of these. Shockingly, these work just fine. For $10, I would hope they still work. I don't need any faders. The potentiometer I can handle. And then, so 16 of those, and then we need 34. Oh, we need this guy right here. $20 out of stock. Ugh. That's difficult. We can repair that if we really, really need to. But then it's going to break again very quickly. It's just what happens. Where are the buttons? I scrolled past it, right? Right? Oh no, do they not have it? I can get it from other places then. I'm going to have to look around. There's a couple of these shops that sell these parts. Yeah, these are Roland MC 505, but they don't have any of the buttons, and all of our buttons are dead because they've been alive too long. All right, well, I'll have to find a shop that has both of them. There's a couple. This is Cintar. I think there was another one like Synth Shop or something like that. Oh man, what a crazy thing to fix. Well, once I get it fixed, I actually get to learn how to $50 for one component. No, it was $50 for 16 of the component. But they're like the only game in town that has them. There's like 2 or 3 places that have them, so they can jack the price up. It looks like they want you to use these, which are not the right color. You can get a set of 10. Yeah, I don't want to spend $1.95 on 30 of these. Yeah, they don't. So like DigiKey and the other suppliers, they don't have these. So we have to buy them from these places. But buying them from these places means that we know that it is a valid replacement part that'll feel the same way as the old one. And they've got all this plastic too. I wonder where they got all this plastic. Do buttons go bad even when they're not cycled? No, I don't think, yeah, I don't think anything. Well, thank you for the bits. No, they shouldn't. Those bits weren't enough to trigger the light. I have this light on my desk that's hooked up to all of our Node Red stuff. So if somebody says idea in chat, the idea light lights up. Wow, what a great idea, chatter. Whoa, you're super cool and smart. But if the bits are below a certain amount, because this does different colors and stuff, it's one of those hue lights. Wow, you're so smart, Childrew. That's so great. Thank you. Oxygen is the enemy on a lot of old connectors. Oxygen and mechanical wear, because these things should have a modicum of, because they're like stainless steels, right? So these should have a modicum of corrosive resistance. Oh, the microscope froze. That means I need to stop. Just as a whole, just stop. Quit Stream Deck. Quit. And then I need to go to the microscope. And then I deactivate. Activate it again. I use webcams. I don't use those more expensive cameras. Oh, hold on. Deactivate it. Jiggle the cable. This is a USB like micro, not a mini, which is a hateful plug. And I've wanted to tap this so that I can have a screw that holds this thing in place, or just convert it to USB-C, which would probably be the best thing for me to do. Because USB-C has that little click detent, and you can also get screw-in type USB-C. So that would be the best for this. I gotta focus on this one day, make my equipment work. So the Logitech webcams. Logitech webcams love to forget their parameters and what you've set them to. It's a driver issue, and Logitech cannot be fucked to fix it at all. They just don't care. Logitech does not care. And these webcams are so cheap and old at this point. So what I do is I run a macro on the Stream Deck. Me and Justin are the 2 people in this world that get 100% out of their Stream Decks. There's a lot of functionality on this, and Justin of Djibouti Show uses a lot of the folders and stuff. I use a lot of the camera controls in order to do focus and things like that. And then I also use it to control all the lights in the shop, which is kind of neat. So anyway, I've got these macros programmed for setup. And what they do is they take the camera and they fiddle with the settings, and then they fiddle with them again. And that like kicks the camera back into working properly. If we look at the microscope right now, there's like kind of trails a little bit. It's actually doing okay. Sometimes it's really, really bad. But if I do the microscope procedure, we will see the color coordination change just a little bit, and then it changes back to my 4300 setting where things look natural. My handwriting doesn't, but things just look good. And there we go. We got all that stuff going. So yeah, I have a lot of like integrated stuff going on right now. And my favorite one is the blood glucose meter. That one's kind of the dumb looking one. Hold on. Where's the good one? Oh, I think this button is activating the wrong one. Yeah, that's the wrong scene. The scene I'm looking for is the framed one. See, that looks a lot better. This is actually my blood glucose as of 5 minutes ago, on a 5-minute delay, and if you look in my Discord, you can see where it is. It's a website that you can go to. It's a Heroku app. And then we've got the scope over there. The oscilloscope is actually more like an Android device because Rygal has updated all their stuff, and that means that I can show the scope on screen, so I don't have to have... I used to have to get a shot of the scope in the background at all times. Now I can actually dynamically give you guys a good view of what I'm doing, and then we can see at 60 FPS and enough clarity what's going on. So yeah, there's a lot of cool stuff that we do here with circuits. Oh, I should put this in a different part. Where is that? Frame BG. This is what happens when I don't have it on the Stream Deck, because I can't find it. So yeah, for those of you that haven't been here, this is my shop. I've been doing this for like 10 years. And we work on like silly circuits and stuff like that. We've been doing a lot of variety stuff, and I've been trying to move a little bit into music. Tomorrow, I'm going to be streaming the same bat time, same bat channel. You guys can catch me with my buddy Julian. I got to move around a bunch of furniture tonight, and we're going to get him in here, and we're going to be able to get his synthesizer stuff running. And we're not going to get the 505 working. I got to order a ton of parts for that thing. But yeah, we're gonna do music and building stuff. I don't know what I'm going to be working on, but yeah. Next step: give us control of your insulin pump. Maybe next time. Maybe next time. Maybe... Oh, geez, that was the wrong one. I gotta change that button. Frame BG. Go away. There we go. Yeah, all right. So the 505, I'm gonna have to order like $100 in parts for. I expected that. That brings the grand total to like $350, which is probably what you could spend to buy one that's not broken, but we are getting a bunch of soldering content out of it. Can you do anything with the 505 in the state that it's in? I don't know. Two problems with that. Two problems. One, I don't know how to use the 505. It's kind of a beast. It's kind of like a menu thing in terms of sequencing. I don't know. I couldn't even get it to play Psytrance, but that's due to the number two. Number two is that a majority of the controls on this thing are dead. Everything I have circled is dead. So there's not a lot, and then all the keys are like intermittently making contact. It's kind of a mess. So I don't know. You know, I'm also wondering if these 8 buttons, 7 buttons work as well. I know tap is okay, but these don't seem to be working so much. So that's 35, 36, 37, 38, 39, 40, 41 buttons that I gotta buy. Why is everything vibrating? There's something weird going on outside. There's like an electronic hum. Do you guys hear that? You guys probably don't hear it. But yeah, the 505 in the state that it's in right now, even if it was fixed, I probably couldn't make too much on it. We could play around and start learning it, but while we're on the gear, I missed what kind of lens for the microscope view. That's a complicated and long story. Actually, it's not. Kurokesu sells enclosures for Logitech webcams. They stopped selling them because they're old, but they still have... Kurokesu has a lot of really good like lab equipment. And so back in the day, 2016-ish era, I bought the aluminum enclosure for the Logitech C920, transplanted it in there, and now it has a C-mount microscope lens, to which I bought on Amazon a C-mount to Nikon 18mm adapter, whatever type of lens that is. This is the lens that everybody hates. I bought a DSLR in 2006. No, I think it's 2008. I bought a DSLR with like tax money coming back from the man. I was like, look at all this money. I'm going to buy a camera. Turns out that camera has to sleep the image sensor in order to use as a webcam. So that was a bad investment on my part. I can't use that camera here as one of my webcams. So anyway, the lens sitting around, put it on that, and that gives me all of those distances from the sensor, and the fact that this sensor is very small and this was meant for a big sensor, that gives us this 2.5 foot standoff from our subject, which is really useful because a lot of my tools are tall. Not that tall, but they're kind of tall. And getting under like a real microscope would be kind of difficult. Plus, it's a webcam, so we get full FPS, full color grade, all that stuff from the same Logitech webcams that I'm using. I had to put an infrared filter so that all of those blue-hued infrared light beams wouldn't get into the sensor. Every single camera sensor, every one, has to have some kind of an infrared pass filter on it, or else, at least like 99% of the modern ones do. Your phone, even if you think that front-facing camera does not have one, it has one on there. It cannot view infrared well. Some gets through because there's not a lot of room to have a big deal pass filter on it, right? So I had to buy the filter separate and glue it in just on top of this thing. And then I put a UV filter on the bottom too, just to make things look a little bit more, I don't know. I think the UV filter makes things look a little nice. So, so anyway, that's how I'm able to have such a powerful soldering microscope. Why is the bottom of my arm purple? Okay, that's not purple. That's just the lighting that I'm getting. Why is it so red? Because it's been resting against the desk. For us to view things like little, hold on, let me get my little, this is a hard drive. For us to view things up close and electronical in super high quality. Plus, this is the microscope that I view through OBS. And so with the OBS monitor, because that's where I work, and then up here's where the monitor is, I'm looking at that monitor when I'm streaming to you guys, and when I'm working on electronics, I'm looking straight across. My back is straight. It helps out a lot. All right, if you can't tell, I don't have any more content. We just troubleshot the 505 to within an inch of its life. We know everything that's wrong with it. It all has to do with usage, wear and tear, pushing the buttons, using the device. That's cool. That means this thing is a freaking warrior, that it went through a lot before it was sold on eBay as broken, which is fascinating to me. And I think it's kind of cool for us to replace all of those worn out user interface devices and have a fully functional musical device. That's going to be really cool. Unfortunately, I can't really repair these here personally. It would involve taking apart each of these buttons on the scale of what I just did by peeling away all of the little rivets, and then we'd have to rivet them back again. And doing that 36 times is not worth my time. So what I'm going to do, let's unplug 120 volts here. What I'm going to do is order all the parts. And so we'll get a big bag of parts. We'll be able to do a bunch of like through-hole soldering, and then we can put the thing all back together. Cool. So, yeah, that was stream. Hey, that was a good one. I enjoyed that immensely. We learned a lot. The weird stuff that it's doing in order to multiplex all of its buttons and stuff is so strange. I like taking the IR filters out of old CCTV security cameras. Many moons ago, I did a wall of CRTs. Oh, that's cool. With a, yeah, like a wall of CRTs or like a pile of CRTs in the middle of a room. We used to do that for a lot of the raves. We would take there were all these security CRTs that were left over. So we just would pile them in like a circle in the middle of the room and make a big display out of them. Curiosity art piece for Halloween thing felt very much like someone from Lawnmower Man. The problem with those kinds of viewers though, is that you can view through clothes. Sometimes it's bad. I'd seriously try soaking and pressing those buttons in some electronics cleaner, then letting them dry to see if you can save them without taking them apart. I kind of want to just replace them all though. You have a point, but all the soaking is like, I can spend $40 and we'll see what a pack of 10 costs. Cause I don't know if it may not be a soaking issue. All of the yard work is going on. We got 4 Seasons Total Landscaping. Yes, that one. Here, they work on our neighborhood, and so I'm trying to get this in the view. And so I think that mechanical buzzing that I'm hearing is them. Yeah, look at that thing. Whoa, did I just put a huge... Whoa, 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 wee-wah. I don't know, sure looker might be right. I might have it exactly, actually. I don't know if I could get electronics cleaner in there. Also, that thing just flew away and I don't know where it went. It's gone. I don't see it. Where did it go? I'm not doing this 34 times. I guess pushing on them is a little less involved. You know, push the buttons while they're under. My coffee is empty. It's a shame. Yeah, I don't know. Could contact cleaner get in under there and clean it? That's very possible that it could. Because that, I mean, this is fine. It still has that crunchy click over to it. I don't know where it went. Where did that? Oh my God! It made a little tick noise and then it vanished. You know, usually I deal in parts that are that small. There isn't exactly an environmental seal between the button and the dome, but it is very restrictive space to get into. Yeah, that's what I was thinking, is you'd submerge it and then click it a bunch, and maybe that would pump fluid into this area, and then you'd need to, like, maybe use a toaster oven to dry it. Yeah, into the cat dimension. Because when you click over that dome, all it's doing is pressing down onto these things, and you can see if I touch it with the tweezers, it's like brushing stuff off. I mean, okay, so that would be an emergency thing. I think I'm going to order buttons first. I just don't want to. I don't want to deal. I would rather have new stuff that's not going to, like, break in a little bit. Maybe I could grab some of the bad ones that we remove and we could try that. I do have an ultrasonic bath. Hold on a minute. Chat, you might be cooking. Get out of here, AI. Ugh. Man, I'm gonna have to get used to going to DuckDuckGo soon. Oh, not Facebook. No. Wait. No. Has anybody used an ultrasonic cleaner to clean buttons and knobs? Thoughts on this one? From Scrap It Audio and Video. It is a coating that is flaking off. They're coated and painted. You'd have to sand them. Okay, maybe not exactly what I'm looking for. Okay, here come the hovercrafts. I'm probably going to have to... Okay, if you guys... Maybe you just hear me yelling, but we've got lawnmowers descending on this area, so I guess they're doing Fridays now, but I have to raise my voice so I can hear myself talk. This whole shop is about to be filled with two-stroke exhaust. So what we can do is I can take all the buttons off and we'll throw them into the ultrasonic cleaner to see if that'll do anything. The ultrasonic cleaner will probably get a bunch of stuff in there, and then I'll have to use probably the toaster oven that I have down here and just run it at like 100 degrees or something, 120, just to make sure that everything kind of boils off and gets clean. I don't know what cleaner I'd use. If I'd use alcohol, maybe just boiling it with alcohol in the ultrasonic, maybe that would do it. But I am gonna have to order buttons because I blew up this one. This one will not go back together. But the other ones, without taking them apart, maybe I could. It would be something just to try. So can you guys remember that for me? Because I'm gonna order these parts and I don't know, they're gonna be shipping internationally. I don't know when they'll get here. Here's the end card because I am just wrapping up. Yeah, isopropyl I think is the best bet because that'll at least clean up nicely. I don't know what I'd use beyond that. Anything else would damage the plastic, and I just don't want it to damage the plastic. Thank you guys for joining me. This was fun. I actually had a really good time doing this. We're not done yet. The really fun part, the visually fun part, is coming up once I get parts in the mail. Yeah, until then. Oh, and I never showed off for the Djibouti guys that are joining me. Every time somebody says Willow in chat, and I have a button to activate it, pictures of my little puppy appear. Look at her. She's such a good girl. She's a a little weird. I need to put more pictures in here, but yeah, this is one of the little things that I got going on. Anyway, I'm gonna go take that dog for, well, actually, no, I'm not gonna take her for a walk. She's gonna be hiding from all the noise. Is contact cleaner different from isopropyl? Well, I don't know, you know? Contact cleaner probably has some other detergents in it that help break stuff out. So maybe that's what I want to use. I see somebody saying that Windex works for switch contacts and ultrasound. That'll also have detergents in it. Maybe I can try that. I've used Windex to clean everything anyway. Anyway, yeah, I would continue on if I had content, which I kind of do, but I need to rearrange the room a little bit so that we can get Julian in here tomorrow. We're going to be doing music stuff, more music stuff. I don't think I'll be repairing anything on the 505, although we could start to take all of the buttons and switches off that are bad, and we can see whether or not I can find that potentiometer. And I can tell Julian exactly how screwed up that thing was. We were sitting there hitting buttons like Neanderthals, like, oh, why isn't it working? The ones that I can't do cleaning on are the keys, the rubber button keys, because those have plastic formed around rubber, and so that's going to create a seal. There's no way to get into that button. Contact cleaner is not isopropyl. It depends on the contact cleaner that you're buying, but okay, guys, I gotta go. I gotta go. Is anybody on? Can we like throw you guys a gun out or something? I don't think so. I think Rabaz is on. I don't have enough people to raid into Rabaz. You won't even notice me. Notice me, senpai. Doug is coding a Mario Brothers game inside of OBS. What the? That's fascinating. I don't have enough viewers. It would be like 2 people walking in and going, hey. I could throw you guys at Dave, but he's playing Path of Exile. EJSA Science and Tech is doing Space and Rocket review. Benji is still on. He's been streaming all day. Like, he was streaming when I woke up. Crazy. Okay, never mind. I'm just gonna, we're just gonna stop because we're gonna come back tomorrow. Dichlomethane. What? That's hard to say. Because those spells are difluoromethane. The fluoro element makes it light and airy. I don't know. All right. Anyway, whatever. I don't care about what's in contact cleaner. I'm going to stop streaming now. I need to stop streaming for me. I will catch you guys later. And until then, I will be back tomorrow on Saturday, and we'll have Julian here, and he'll have his own table and everything. I have a lot of cleanup to do until then. I've been procrastinating about it, so I'll catch you guys later.